Hello everyone, welcome to Prompt Engineering course, and in this course we will be discussing everything you need to know about prompt engineering. So what is prompt engineering? You can imagine yourself as a chef at a fancy restaurant. You have all the ingredients at your disposal, but without clear instructions, that delicious dish you envisioned might turn out quite strange. In the world of AI, prompts act like those instructions, guiding large language models to create content that you desire. So, prompt engineering is basically using the most of your LLMs. It is basically about making the most of it. The better your prompts, the better the results you get. Because LLMs are capable of a lot of things, but they need clear instructions. Unless you give them that clear instruction, there would be something lacking. But not to worry, we will discuss that in this course. We will take care of what needs to be asked to LLM to get that perfect answer. But how do we do that? We do that by asking a prompt. We pass a prompt to the LLM. Now, what is a prompt? A prompt is a piece of text that instructs an LLM how to complete a task. It can be a simple question, a detailed command, or even a conversation history. The key is to provide the LLM with enough context and information to understand what you want it to do. Here are some examples of prompts. Simple question: what is the capital of France? But a detailed command could be: write a poem about a robot falling in love with a human in the style of Shakespeare. Right? It could be a simple question. It could be a complex question. Depends on what you want to know. If you just want to know the capital of France, a simple question would work. But if you want to write a poetry in Shakespeare's tone, then you have to give in details, right? If you want to set a scene and make the poetry a lot more dramatic, you can give that. You can give those details in that prompt. So let's say the user says, I'm feeling overwhelmed by the to-do list. Then the prompt could be acting as a productivity assistant. Don't worry, I can help. Let's prioritize your task and create a schedule that works for you. Right? So it's basically understanding the user's needs and giving the answer. So if the user has a list and the user is not sure what they want to do, so LLM should be capable of guiding them through it. It should be an easy flowing conversation, right? But that is something really advanced. Initially, your LLM will have certain knowledge, but you will have to tell it how to use that knowledge. That is prompt engineering. You tell the assistant that how it should be behaving, how it should be acting. That is prompt engineering. If you want your prompts to be formal in tone, you can tell that. If you want it to be informal, if you want your robot to talk like, maybe your LLM to talk like a Shakespeare, or maybe you want it to talk like pirate, you have to tell that. You have to tell the tone, you will have to tell how helpful it needs to be, the things it needs to take in mind. All those things you'll have to specify. And all these things which you're specifying is nothing but a prompt. Right? So that is prompt. Now, why do we need prompt engineering? Why is prompt engineering important? Prompt engineering is the art of crafting effective prompts. Just like a chef needs that right recipe, LLM needs what designed prompts to produce the best results. Okay, so you need to provide a good prompt so that the LLM can follow the instructions and give you the correct answer. Everything what you need. Because let's say I ask LLM to do maths and give me answer to a mathematical equation. LLM is not good at mathematics, so it may give me some random answer. But if you ask it to actually perform the operations and give me the result, if you instruct it to actually go through each and every operation to solve that equation, then you will get a correct answer. So it is basically how you emphasize on the task in hand, right? That is why we need prompt engineering, because not everyone can be clear enough. You need to specify things in great detail so that you get those kind of answers. If you give something very top level, if you just tell it that give me a recipe including mushrooms, then it might give you a recipe. But if you want it to be a very specific thing, maybe I want a different mushroom curry which has some coriander or some specific spices, I need to specify that, right? So that is why we need prompt engineering, to actually know that how to tell LLM what we want from it. Okay, now the importance is that it will allow us to actually get the accuracy and control. A good prompt steers the LLM in the right direction, ensuring the information it generates is accurate and relevant to your needs. Then it provides style and creativity. Prompts can influence the style and tone of the LLM's output. If you want a funny story, if you want to craft a prompt with a humorous slant, you need a formal report, you want to use more serious or objective tone, then this is what we can get from prompt engineering. If you want efficiency, you can basically give effective prompts which can save your time and effort. The more specific your instructions are, the less likely you are to get irrelevant or nonsensical outputs from the LLM, right? So basically, in essence, prompt engineering is the bridge between you and the vast potential of LLM. By understanding how to craft effective prompts, you can unlock a world of creative possibilities and get the most out of these powerful language models. Now, what will we be using for this? And how does it really matter? We will be using Llama 2. Now, Llama 2, okay, but what is Llama 2? Llama 2 is a collection of large language models developed by Meta. These AI models are trained on massive amount of text data, allowing them to generate text, translate languages, write different kinds of creative content, and answer your questions in an informative way. Now, what is it? It is a family of LLMs ranging from 7 billion to 70 billion parameters in size. More parameters generally indicate a more powerful model. And what is it used for? Llama 2 is particularly strong in dialogue applications. Thanks to the Llama 2 chat versions, these are fine-tuned LLMs specifically designed for chat conversations. You can use them for tasks like creating chatbots, building virtual assistants, or even having interesting back and forth discussions. So, why are we choosing Llama 2? So, let me give you a quick comparison of Llama 2 with the other big players in LLM world. One is OpenAI. Now, OpenAI is a prominent developer of LLMs. With well-known models like GPT-3, both OpenAI and Llama 2 offer powerful LLMs with strong text generation capabilities. However, Llama 2 chats focus on dialogue applications, and they might make a better choice for chatbots or virtual assistants, right? So, if you want to make a chatbot for yourself or a virtual assistant, you might go towards Llama 2. Another thing is that Llama 2 is free to use, so you can set it up in your system itself. while in case of OpenAI, you cannot make much modifications and you will have to pay for it. You will have to take a subscription and you will have to use their APIs, right? So a little difficult. So it's better to prefer Llama 2 here. Next thing, Gemini. Now, as a large language model, Gemini shares many similarities with Llama 2, and they both generate different creative text formats, translate languages, and answer questions in an informative way. However, there might be some underlying technical differences in the training data and architecture, which could lead to subtle variations in the output. But again, in case of Gemini, as of now, it is free to use, but from May 2024, there would be certain changes and you will have to have a maybe pay as you go kind of a subscription. So if you're willing to do that, you can use Gemini also. There is no restriction in usage of OpenAI, Gemini, Llama 2. Just open their documentation and you will be able to get their keys and then you will be able to make use of them. That is not a big issue. If you want to use those, you can do that. But in this course, we will be using Llama 2 because it is free of cost. Now let us talk about Llama 2 version versus Llama 2 chat version. Now Meta has released Llama 2 and Llama 2 chat versions. Now Llama 2 is basically an updated version of Llama 1, and with Llama 2 they have basically increased the pre-training corpus by 40%. And they have also doubled the context length of the model. Now what is context length? Context length is basically the number of input tokens can be passed into the model. Basically, when you're asking the question in form of a prompt, the length of the prompt has actually been doubled for it. Okay, now for Llama 2, there are two different variants, Llama 2 and Llama 2 chat, and within Llama 2 and Llama 2 chat there are three sizes. One is 70 billion parameters, 13 billion parameters, and 70 billion parameters. They had also trained a 34 billion parameter variant, but they have not released it, and they have only released these 7 billion, 13 billion, and 70 billion parameters. Now, when we talk about these different sizes, you can obviously assume that these are really large models. Like when they say large language models, they are actually very large in size, because 7 billion, 13 billion parameters are not very small numbers. These are very large models which we are talking about. Okay, so the difference between Llama 2 and Llama 2 chat is basically that Llama 2 chat has been fine-tuned and optimized for dialogue use cases. Otherwise, the models are somewhat similar. Basically, it has been fine-tuned again. So basically, Llama 2 has been fine-tuned to work better with chat in case of Llama 2 chat. Now let us see how can you actually access Llama 2 models. So for accessing Llama 2 models, you basically have three different options. One is using the hosted API service, another one is using the self-configured cloud, and the third one is hosted on your own computer. So what you can do is you can download the Llama 2 7 billion parameters 4-bit model. Now this 4-bit model is basically a quantized model, right, where you decrease the size of each of the values which are saved, right, the model weights. You decrease the size of them. Usually they are trained on 13 bits, but you can actually reduce the size, basically the precision of these saved values from 32 bits and reduce the size of it by reducing the precision and saving it in 4 bits. This actually does impact the performance, but because it is such a huge model and the impact is not that much, the impact is negligible. So that is why we can use a 4-bit model, right? And again, you have the option to use 7 billion, 13 billion, or 70 billion parameters model. So that is completely up to you. You have to actually decide which model size you want to go for, right? Now, apart from that, we have certain inference configuration parameters. Now, because when you will be making use of the model, when you will be prompting the model, there are certain criteria which impact how you get the result. Okay, one thing would be your system configuration. Basically, the system value which you're providing. There is a value related to system, which is basically a rule which you provide to your model. This rule could be like, you need to talk in a formal tone, you need to talk like Shakespeare, you need to give sarcastic answers, or you need to give funny answers. So this is the system rule which you define. Apart from that, there is a prompt which you will be giving. This prompt will basically give it the task which it needs to perform. And thirdly, these are the different inference configuration parameters which you will be providing to your llama model. Okay, these parameters are basically max new token, sample k top, sample top p, temperature, etc. So there are several different configuration parameters present. Now let us see what these are. Now, the first one is basically the max new token length, which is basically setting the maximum number of words the LLM can generate in response to your prompt. Okay, so basically imagine it as a word limit. Okay, for example, if you set the max new token to 50, so the LLM will stop generating the text after creating 50 new words. Okay, so basically if you are generating say 100 words, now it will not generate 100 words for you, because these 100 words will have to be generated following your prompt length. Okay, so basically the max new token length is basically the maximum number of tokens which are generated, and this will be concatenated to the context which you will provide, concatenated to the prompt which you will be providing. Okay, so basically this will be useful in controlling the length of the poem, emails, or short stories which you are writing. Okay, so let's say you have a prompt of 50 words or 50 tokens, and you say that it can generate 250 tokens only in the max new token limit. Then it will mean that 50 tokens which you gave in the prompt and 200 new tokens can be generated. That's it. That is the word limit which you're defining. Okay, so this is the purpose of the max new token. Next we have the top k. Okay, now what is this sample k top? This is basically the parameter which focuses the LLM's selection on the top k most probable words at each step during the text generation. It is basically like having a short list of the most likely words to choose from. So basically it will have a probable answer. It will have a probable answers, a set of probable answers. So you define a top k probable answers. So basically, let's say you are setting top k to be 3. This will mean that the LLM will only consider the top 3 most probable words or top 3 most probable answers for the next word in the sequence based on the correct context which you have provided. So this will basically lead to a more predictable answer, more focused output, but it will also limit the creativity of the LLM. So if you want to get some different answers, more creative answers, then you will have to set the sample k top to a higher value so that you have more number of options to pick from and not a very specific answer. But if you want it to be very specific or focused, then you need to give a low sample top k value. Okay, so let's say I'm asking what is the capital of France, then there is only one answer. So I will set sample k-top as 1. Okay, but if let's say I wanted to generate a poetry, or I wanted to write a story, then I will say sample k-top to be say something like 200 or 400 or 50 or 60, so that I have more random answers generated. I have more random or more variety or more creativity in the answers which are being generated. Okay, now next we have the sample top p. This sample top P is the parameter which focuses the LLM selection on the most probable words that cumulatively add up to a certain probability threshold P. Okay, now imagine it like a probability pie chart. You define a minimum slice size P. Okay, and the LLM only picks words that fall within that slice. So basically you give a probability, say cumulative probability of 5%. So it will pick an answer from the top 5% of the entire answer base. Okay, so that is basically your top P, the probability. That is basically you wanted to pick from the cumulative probability of top 5%. Okay, next we have the temperature. So this parameter acts like a heat dial which controls the randomness of the LLM's word selection process. Okay, now a temperature of 1 reflects the original probability distribution from the model. Okay, and higher temperature, basically any temperature greater than 1, will increase the randomness, making the LLM more likely to explore less probable but potentially creative words. Okay, so you will basically get a more creative answer, more random answer if you set the temperature higher than 1. But if you set the temperature less than 1, then you will have some less randomness in the answer. So it will basically stick to the most probable words. So it will give a more predictable and focused output. So basically, if you want a very focused answer, then you set low temperature, keep the top P low, keep the top K as a lower value. If you want more random answers, more creativity, more out of the box things, then you keep higher top K, higher top P, right, and higher temperature, right? So these are the configurations which we have in case of LLMs, right? Now, to use llama models for prompt engineering, we will first see how we will perform the setup for this llama, so that you can perform your prompt engineering, you can practice prompt engineering for that. So let us go ahead and perform the setup. So in this session, we will start with the prompt engineering practically. So first of all, we need to understand a few things about Llama, okay? So when we talk about Llama 2, the Llama 2 is actually a collection of pre-trained and fine-tuned generative text models. Now there are multiple models which are ranging from 7 billion to 70 billion different parameters. So you can just imagine how big this is. There are 7 billion to 70 billion parameters present in this model. Okay, so there are multiple models with these many parameters, and these are designed for dialogue use cases. Now, it usually outperforms open source chat models on most of the benchmarks and is on par with popular closed source models in human evaluations for helpfulness and safety. Another thing to note is that all these different models which I'm talking about, these all are free to use. So basically, you can use Llama free of cost without paying anything. But if we compare this with the ChatGPT, OpenAI, or Gemini, they will need some kind of membership, some kind of subscription. So we can't really go with them for this particular session, because again, it is not sure if you will be getting or if you will be ready to pay for that. So it's better we'll learn using Llama. And another issue with the OpenAI and Gemini is that you will have to take some pay as you go subscription. Now, these subscriptions allow you to call their APIs or use their models directly. But to actually be able to fine tune them or to be able to perform different modifications in the model itself, or to maybe perform tuning on these models, is not possible. You will have to use something like Llama, which is freely available, and you can make whatever changes you want to it, tune it further, or maybe apply different processings on these models to make them good to use, right? So that is why we will be using Llama. And although we are using it only for prompt engineering, but there are a lot of different use cases which are present, right? Prompt engineering is just a part of the LLM. It is just teaching you how you use it. But when we talk about actually using and building LLMs, there are a lot of different processes involved to it. And we have explained that extensively in our generative AI course with LLM, where we take care of all these topics of how you can create your own chatbot, how you can actually modify these pre-written models, how you modify all of them, how you build your own model for this chat phase. So yeah, that's what we have done. But now we will focus on prompt engineering. So for this, we have used Llama, and this is the session about doing the setup. So because obviously, LLM are huge in size. I just told you that there are 7 billion to 70 billion different parameters which are present, which makes the size of the model very large. So what we will be doing is we need to do the setup. For the setup, these are the standard lines of code which you need to follow. You can just simply copy this from this file itself, because there is nothing much to it. Mainly, we are preparing our environment, and we are installing Hugging Face Hub. This Hugging Face Hub and Llama CPP Python. So Llama CPP Python will allow us to use the Llama model, and Hugging Face Hub is where these Llama models are present. So we will be picking the model from Hugging Face Hub, and we are installing the Llama CPP Python, and we are installing NumPy, which is compatible with it. After that, we are giving the model base name. So this is the model. This model is present in this particular path in Hugging Face. So if you look up in Hugging Face, you will find this model at this given path. And this is just the base name of the model which we are using. And if you see here, it is Llama 2 model with 13 billion parameters. Okay, you can use any other model, maybe with 7 billion or with 70 billion. It is completely up to you which model you want to use. But for prompt engineering purpose, it is better if you use 13 billion or 7 billion, because it won't make much difference. We just want to understand how we can perform on improvise prompt engineering, right? So once you run this, it will start installing the packages. And after installing the packages, you need to import the model. And once the model is there, you will have to use HF Hub download to download the model. And we have llamas underscore CPP from where we are importing the llama model. Okay, so we can run this also. And then we are using HF Hub download to actually download this particular model and the model baseline name from the model path and the model base name. Okay, so this is what we are using, and the model is actually 9.76 GB in size. So it will take some time, but because we are using GPU, so it won't take that much. So if you want, you can do the same setup in your system also, or if you want to use Google Colab, you can use this file directly. Now, once you do the setup, once you download the model itself, you will have to create a object. Okay, so for this we have to set up the GPU details. So we create a llama object, and in this we provide the model path, the number of threads, the batch size, the number of GPU layers which you will be using, and here you can just run this particular line of code which gives you the number of GPU layers. And then we come to prompt engineering itself. So for this you will have to create a prompt first. Okay, so this is a prompt. A prompt would be a text statement which you want to give to your LLM. Now this thing you would have tried at least once on your ChatGPT or Gemini or Copilot, whichever you're using. And there you could have seen that once you type in some question or whatever you want to ask the LLM, it will actually give you certain response. Okay, so what you type in is actually the prompt. Now this is my prompt, which is write a linear regression in Python, and my prompt template is basically, it will contain, one is the system, basically what the system is suggesting the LLM to be. So this is what the system is telling to the LLM. It is saying you are a helpful, respectful and honest assistant. Always answer as helpfully. Okay, so this is what the system is telling. And the user, whatever I will be putting as a prompt is basically, this is for the assistant and this is what the prompt would go inside here. So basically this goes here and then the assistant will answer. So this is our prompt template. So the system will set some sort of rule for my assistant to answer, and the user will give a prompt, and using the system's rule and the user's prompt, the assistant will create an answer. Okay, now here I have written that you are a helpful, respectful and honest assistant. I could have written something like you always give answers in formal tone, or I could say you work in ABC organization, so all the responses should contain ABC organization in context, something like that. Okay, so you give certain guidelines via the system. Okay, so guidelines are given by system, the question is asked by user, and the assistant is supposed to give the answer. So this is our prompt template. And after that, so this is run. Then we use the llama object to actually run the prompt and give us the response. Now here are certain things. One, it takes input parameter prompt, which basically suggests what prompt you're giving. Then max token is the number of tokens. So at max, we are saying that at max, the input could be of 3000 tokens. Now this 3000 tokens is entire thing between this. So this entire thing could be of size 3000 tokens. Now these 3000 tokens could be 3000 different words, and these 3000 tokens can also be a split of the word. Okay, so let's say we have a word like swimming, so it could consider the entire word swimming as a token, or based on how it is taking up the tokens, based on how it um, understands the tokens, it may also take swim as one token and ing as another token. So swim could act as one single token also and two tokens also, based on how your model has been trained to understand the tokens. Okay, this is one thing to remember. Second thing to remember is that whenever we are passing any prompt to our assistant, the assistant is actually charging us, right? We are not in all the cases, like in the free versions which you are using in Gemini, or when you're using the free version of OpenAI, ChatGPT, not that one, but the exclusive version, say ChatGPT 4. So in that case, what happens is it charges you based on the query which you're sending. So if you're sending a smaller query, if you're writing that give me a email draft for leave, then it will consider only the number of tokens there and charge you accordingly. Okay, now if you are giving a larger number of characters inside it, if you're giving a larger, more detailed problem or a complex problem, right, where you're saying, okay, the entire statement is there that write an email draft for leave, and specify that this is the organization name, this is the reason for the leave. So you're adding the number of tokens. So as you add the number of tokens, the charges would also increase. Okay, so this is how usually the charges are taken up for your prompts. Okay, but don't worry, because most of the time uh, it's better to give more number of tokens, because it will still charge you less than having someone to actually research it and give you the result, right? So if I am asking a person to actually find out these details for me, if I'm asking someone to write a email for me, then how much I'm paying to that person to write an email would obviously be higher than what I will be charged for asking the LLM to write a draft for me. So it's always a good idea. Now, getting back to this, so you have written a prompt here. We have the prompt template, then we have the maximum number of tokens, we have the temperature. Again, we have set the temperature to 0.5. Setting the temperature to 0.5 will make sure that we have some randomness in the answers. But if you want to have only the best of the best answer in the output here, then you will have to give temperature as 0. But if you want to have a lot of randomness and something different coming up every time, some variation in the results, then you would pick a higher temperature. Okay, then top P, repeat penalty, top K. So this is it. We can run this. So this will basically create a response. Now we will see what a response holds. So we will run this again, and let's wait for it to give back the response. So here you can see we have written the prompt. So this prompt is write a linear regression, and in the prompt template we have given system, and the system is telling the LLM that you are helpful, respectful and honest assistant. Then we give the user the prompt and the assistant. Basically the system will tell the assistant to be helpful, respectful, and honest. The user will give the prompt, basically the question which we want the assistant to answer, and then we will get the assistant's response. So we pass it through the llama model. We provide the prompt template, the tokens, penalty, top K, and other details, and we get the result in the response. Now, if you see here, the response actually consists of this dictionary. This dictionary contains the ID, the object, I'll take it slow, text completion, then the created ID, then the model details, that is the block, llama 2, 13 billion parameters. After that, we have the choices. Now, choices is basically the multiple responses to it. So there will be multiple responses present here. We have this response. This choices is basically a list. Okay, and in this list we have the first response, that is this text, which is the system is telling. Then we have the details by the user, that is you have to write a linear regression. And then we have the response from the assistant, which is to write a linear regression in Python you can use scikit-learn library and other details. So this is all the code which is present, which is given as the output. Then we have more details. Now after this ends, we have this finish reason, stop. Then we have the usage, that is the prompt token has 39 prompt tokens are there. The completion token took 423 tokens. So the total number of tokens used was 462. This 462 is something which actually decides your cost which you will be paying in case this was actually payable. Basically, if it was some subscription, then the total token counts actually decides how much you will be charged. But let us see the response. Now this response, from response we picked the choice from the dictionary and we took the 0th response and we got the text out of it. So this is the result which we are actually focused on, which is the system, then the user, and then the assistant. This is from the template which we provided, and then this is the response, the entire thing, the entire code for writing linear regression. Okay, and if you see in the end, it is also giving some comments. This will output the coefficient of the linear regression, this will output the predicted value, this will give you an idea of how well the model is performing and whether it is good a fit for the data or not. So it is giving some comments also. It is not just giving the solution, it is also giving what is doing what is used for what, right? Those kind of details also it is giving. So this is how you actually give prompts, how you actually use the prompts. Okay, now next thing, so this is the part of your prompt engineering. Next thing what we will be doing is we will have a look at the features of the prompt engineering or the LLM. So the LLM is actually stateless in nature, so we will see that. Now that we have done the setup, we can see that and check that LLMs are actually stateless. Now, what does it mean that LLMs are stateless? Stateless means that the LLM does not have any state present. It means that they do not maintain an internal memory of past interactions with the user. Now, here is how it actually works. So, there are stateless systems. Now, every time you interact with the LLM, it is treated as a fresh start. So, the response is actually based solely on the prompt or the query which the user provides at that specific time. The LLM does not have any access to any information about their previous conversation. So, although you might have had a conversation and given some prompt and got some responses, but for each and every prompt, you need to provide the complete details of whatever conversation you have held earlier. Okay, so it will not keep track of what questions you have asked earlier and what answers it has given. Okay, let's take a very simple example. Okay, so let's say we provided that this is my weight, this is my height. Now tell me what is the BMI. Okay, so it will say, I'm sorry, but I cannot calculate BMI or solely on these basis. Please provide me all the details. Okay, now in the next prompt you provided your location and your age and your gender so that it can correctly calculate your BMI. Okay, but this time you did not give the height and the weight. Now what happens? It will again say, I'm sorry, but I did not get your height and weight, so I cannot calculate BMI. So what happened here is that initially you gave the height and weight, but you did not give other details which are which are required for calculating the BMI. So it was not able to calculate it. And on the second time, when you gave the remaining information, it said that it does not have the information which you gave it earlier. So it does not have a memory to save what question have been asked earlier. So you need to provide the details again. Okay, that happens in a basic LLM. Okay, so LLMs are majorly stateless. It does not contain the information which you have given it earlier. Okay, but there are certain stateful systems also. Okay, stateful systems will basically remember the past interactions. So for example, if you have a chatbot, it may store some information about your preferences, some conversation history, or maybe some details to personalize your future interactions. That is statefulness. But by default, LLMs are stateless in nature. What you will have to do is, you will have to provide it the state in addition. If you actually want to have that statefulness, then you will have to provide the last two contexts or last three contexts of the conversation to the LLM as an input along with the latest prompt. Okay, so if you want it to remember, then you will have to explicitly provide it, but not as a user, but actually as the prompt engineer who works at the backend, right? As someone who configures the LLM, you will have to provide those details along with the prompt. You will have to add this conversation, the initial context, maybe a summary of the initial conversation as a context with the prompt. So if the prompt makes sense to have that context used, then it will use that context, otherwise it will ignore it. Okay, so that is a stateless LLM and statefulness, how you provide statefulness to it. Okay, so let us see how this is actually working. Now let us see how LLMs are stateless. So I will just write a code here. So this is basically a prompt. This prompt is asking, help me write a poem for my friend Jason, and it is asking for response from the llama model, and here we will be printing the entire response and the response which we will be getting. So let's run this, and once we run this, we will get the result for this, that what it will be giving us the result. Okay, now currently we have not set any temperature, we have not set anything. This is taking everything as by default. So let us see what this gives, and simultaneously we will also add some more code below this so that you can see how much time it takes to run as well. So this is still running, and if you see here, we have got the response, and it says that Jason is a great guy. He is always there when I need him, no matter what time or day it is. He has a good heart, and so on and so forth. A lot of things are there. Okay, now next what we will be doing is, next we will ask it to write a card. Okay, we will ask it to write a birthday card, and we are giving certain details about the friend. Okay, and then we'll ask it to run this. Now when we are running this, we have set the temperature as 0.0. Basically the temperature is 0, so there is no randomness. You should get an answer which is very short, and no changes are there. And if I run this again, now see, I have not set any seed here. Okay, so the result should be given based on the temperature. Now because the temperature is set to 0.0, and in the second one also the temperature is set to 0.0, I am expecting that the results for both of these prompts, basically the same prompt ran again and again, should give me the same answer. And I will also change the temperature in the next one. Okay, I will just change it here to temperature to be, let's say, 0.05, and then I will run this again. Okay, I'll run this also. So it ran this once, and it is saying that please help me write this birthday, and I would be grateful if you could include the following elements. He has a pet cat named Mr. Whiskers. He is turning 10 years old. So it is just giving some random details. Okay, so it is just saying, it is saying help me write a birthday card, and it is giving certain details. Okay, he likes long walks on the beach and reading in the bookstore, different hobbies, different colors. He likes pandas. Okay, and here is the completion what it has given, that he has a pet cat named Mr. Whiskers. He is turning 30 old today. Please help me write helpful birthday card. I would be grateful if you could include following elements: a warm and personalized greeting, and certain details. And then when I ask it to give the same response again, okay, this time I gave the temperature 0.0, so it gave this result. I again gave the temperature 0.0, and it again gave me the same result. Okay, the pet name is also same, Mr. Whiskers. So what happened here is, because we set temperature to be 0, so it gave me the same response, nothing different. And if you see, this response is something which is not really acceptable, because I asked it to write the birthday card for me, and it is actually completing the response, it is actually completing the prompt for me. Because what is LLM doing? The LLM's main task is to complete your sentences. Originally, when LLMs are trained, they are trained on particular data, and it is trained on data to complete a sentence or a complete text. Okay, that's how LLMs are trained. So here what it is doing is, based on the data which we have given, that these are the different details about my friend, so it is trying to make up certain details about my friend. It is not actually writing the birthday card, but it is making up details about my friend. So that is also fine, because during prompt engineering we will have to give it some examples or something like that to get a better result. But currently we are just having a look at what type of responses we usually get. Okay, so currently you just need to focus on that. When we are setting the temperature, it is giving me the same response, and when I set the temperature to be, say, 0.5, it is giving me a different response, that he has a pet cat named Fluffy, his birthday is coming up soon, so I want to write a special card. So same thing, it is completing the sentence for me. Okay, now this is what temperature does. Okay, so you get a feel of what temperature does. Similar kind of response you will get with some modifications you can try with the max token limit, with the top P, top K. Based on that, you can just try out, just try certain variations and see what responses you get out of it. Okay, Now you have seen that this is my first prompt. Okay, in my first prompt I have simply asked it to write something and it has given me some completion details. That is fine, we will be able to modify this, we will be able to get better results out of it. But first thing we need to see that, is it really stateless? So let us try the next part of the code. So here what we are doing is we are creating another prompt. So in this prompt we are saying, oh, he likes teaching. Can you write this to include that? So we are asking it to rewrite this so that it could include that he also likes teaching. And then we are running this. So let's see what we get as a result from this. So it is again generating the result, and once it generates it, we will be able to see the response. Now it is taking some time even on the GPU, but it's fine, we'll just wait for some time. So this is the response. So it is saying he has a pet cat named Fluffy. Okay, we need the response to. Okay, let's get the response to here and run this. So here, so sure thing, here's the updated version. Doctor last name is highly respected and accomplished professor of field of study, and with over number of years experience teaching and research, he has proven track record and so on and so forth. In addition, into his academic accomplishments, doctor is also excellent. So what it did here is that it created a draft kind of a thing where it is basically writing, it is rewriting this. Oh, he also likes teaching. So it is assuming that if someone is liking teaching, so probably he is a professor or something. So it actually wrote a complete draft to give details about some teacher. Okay, and it completely forgot what we were doing earlier. We were writing something about this person whose birthday was coming up. So this is what LLM does. It actually forgets about what prompt you gave earlier and writes something completely vague based on the latest prompt. It does not have any context information from the past. So that is what we need to handle while we are performing prompt engineering, and we need to make sure that your prompt contains all the required context. It has all the task and everything in detail explained, so that your answer is actually something which makes sense, what you actually desire, right? Whatever you actually need to convey to the model to get your exact answer, that is what we want to do here. But it is a stateless LLM, so we will have to perform a few more steps to get the best result out of it. So yes, it is stateless in nature.
So now we will talk about quantization of models. So usually what happens is that the LLM models are huge, and when I say huge, they are very, very, very huge in size. Now, these models usually are in a standard size, somewhat like 7 billion parameters or 70 billion parameters for llama, you can say. Now, this large size of LLM makes it very useful, right? We are able to use it for prompting and we are able to get a lot of information out of it. We can make use of it, and these uses are endless. But the issue is that while training these models or while using these models, a large amount of space and compute is required. So even if I want to get some response from these models, then also I will have to use a lot of compute for it. And sometimes it might takes 10, 15, 20 minutes to get the response. But we don't want that, right? We want the response quickly, because if you wait for ChatGPT for 15, 20 minutes, then it doesn't make sense. because sometimes you just want some responses very quick. Will you really use ChatGPT or Gemini if the response is coming back in like 5 minutes or 10 minutes or 15 minutes? You won't wait even till 1 minute, I must say. Right? So same thing goes here. We don't want to wait and we don't want to put in so many resources. When we are running these models, we want to run it on a maybe a smaller GPU. Some people might want to run it on your normal laptops. So not everyone has that much resources. So we want to use them very judiciously. So what we can do is that, because while training these models, you can't hold back. You can't say that, okay, instead of training it with a 64-bit, let me train it with parameters which are holding only 4 bits. Because then your model will not perform that well. And the training will also take a lot of time. And the performance may not be that good. So we cannot hold back while training the model. Then what should we do? So what we usually do is we train a full-fledged model. Okay, your parameters are parameters which are saved in larger size, basically maybe 64 bits or 32 bits. And then you basically decrease the size of these memory which each and every parameter is taking. Okay, so instead of each and every parameter taking 64 bits or 64 bytes, you basically convert it in such a way that it actually takes maybe 4 bytes of memory. Okay, but when you decrease the size from 64 bytes to 4 bytes, the uh, this particular information will be lost. So if you see here, we have this floating point 32 data. So basically, initially my each and every parameter was floating point 32, okay, and it was taking 4 bytes of memory. While taking this 4 bytes of memory, it was capable of saving this pi value till so many fractions, 30 23 bits in fractions itself. Okay, and when we decrease the size in which this data is saved, the some amount of information is lost. So instead of being able to save 23 bits, if we use BF float 16 instead of FP32, we will be able to save only 7 bits of the fraction. So rest of the information is lost. Now instead of BF16, if you use FP16, you will be able to save a fraction bit, basically 10 bits of fraction. And if you use int 8, you will be able to save only this much. So basically you will have 7 bits of fraction saved and only one sign bit. So a lot of information will be lost. So we want to compare that. We have to decide how much information loss can we actually allow in this case. So basically we have all our parameters which have been trained to FP32, and then we just ask the model to decrease all those parameters size to a smaller size, and this smaller size is int 8 or b float 16, and this way you save memory. You save half of the memory here. Initially it was taking 4 bytes, now it takes 2 bytes. So your model being a size of say 8 GB now will take only 4 GB space. And similarly, the compute will reduce. Similarly, the time taken for inference will also reduce, right? So this is what quantization is, that you decrease the size of the parameter value being saved, which will impact your accuracy slightly, but it will improve the speed it and it may also decrease the compute which is used for making inferences. This is quantization. And here we have a small chart where we have memory needed to store one value. Then this is the size. So if you see, the size is basically, here we have 32 bits, 16 bits, 16 bits, and it is taking 2 bytes of memory. So to give a standard value, you might want to go to bfloat 16, because in case of int 8 you will lose a lot more information comparatively. So we will play a little safe and go till bfloat 16 when we are performing quantization. Now let us have a look further. So when we have a full precision model is the model which has not been quantized. So in that case, if we have a 4 GB model with 32-bit full precision, then the GPU RAM needed to store 1 billion parameters would be this much. So for 1 billion parameters, this much memory will be needed. A very small amount of memory will be needed. And this is the GPU RAM needed to train larger model, to a model with 1 billion parameters. Now, if the number of parameters increase, if there are 175 billion model parameters, then this is the increase in the size of model. Basically, the increase in size of RAM needed to train this model. And instead, if you have 500 billion parameters, then it will also increase exponentially. So in this case, what will happen is that when the model size will increase, you will have to split your model into smaller GPUs to train it, but still it will need a lot of compute, and it will not be feasible if you want to train something for just maybe a trial or something. So it is better that you use a model, you basically use a quantized version, and this will actually save the RAM which is needed to train the model. So it will, in case, also save uh, your different compute and the resources which you are planning. It will save money for you, right? So even in large organizations, we can't afford to lose so much money. So we will still want to have models which are maybe quantized till 16 bits, right? Because in that case, you will be using half of the resources. Okay, so that is what quantization is. Now, there are different types of quantized models. There are GGML model, GGUF model, GPTQ, and AWQ models. Now, this is the chart which you can maybe keep handy to understand what each one is used for. So let us read through this. So the first one is GGML model. GGML is basically general purpose generative model for low resource language. Okay, so this is basically low resource model for low resource languages. Why do we need it? We need it, basically it is designed for efficient training and use with low resource languages, basically where we have fewer training data examples available. So it has basically uh, it is capable of being trained on a smaller data set, and the major use case, basically primarily it is used for tasks which involve languages with limited training data, which allows it for a better performance compared to applying large models to such languages. And the size of this model can be smaller than a full precision models, and the performance basically would probably have a lower accuracy in comparison to a high resource language model, but it is mainly made for low resource setting. So if you want to have something which is trained on a limited data set and trained on a smaller data set, less number of languages, and you don't want it to perform so many tasks, you want it to perform smaller number of tasks, then you can go with ggml. So this will not take much resources, but again the performance would be quite low. When we talk about gguf, the gguf is generative gpt update format. So this, in this gguf, the format has been updated, and it is mainly used for efficient storage and loading of GPT models. And its main use case is that it speeds up the deployment of GPT models by enabling faster loading and potentially better resource utilization. So, in comparison to GGML, it will have a faster deployment, and it will have a better performance. And here you can use it for both GPU and CPU, and mainly GPU is preferred for loading because GPU is faster, and it is mainly used when you want to deploy a pre-trained GPT model, right? When you want to use a pre-trained GPT model. Next is GPTQ. Now, GPTQ is basically used, it is generative pre-training transformer quantization. It is mainly used to reduce the model size and improve inference speed of GPT models. So basically, this will be used mainly on GPU because it will also improve your performance, and it is smaller in size, and it will have better speed, but there would be slight decrease in the performance. So the accuracy will basically decrease a little bit in case of GPTQ, but it will have a faster inference speed. So if you want to have a model which basically gives response very quickly, then you will go with GPTQ, because both of the other ones are quite slow in comparison to GPTQ. And while in case of AWQ, again, it is fast. Now, another thing about GPTQ is that it is significantly smaller than the original full precision model, and it offers substantial speed improvement due to the small model size, and it also has less computation resource requirement. So it may have a slight decrease in the accuracy in comparison to the full precision model, depending on the quantization level which is on it. So if you have a very low level quantization, so let's say from 32 bits you're going to 8 bits, then the speed would be very much, but the accuracy would be very low. So you will have to take care of the trade-off of speed versus accuracy. Okay, then the last one is AWQ, which is adaptive weight quantization. So in case of adaptive weight quantization, what happens is that it makes sure that it is quantizing the weights and the selecting weights which are actually needed for more for making the inferences. The more impactful parameters, not all the parameter weights would be changed. It will modify the weights which are um, more important in making the inferences. So it basically is used when we have want to dynamically adjust the quantization level of model weights during the training, and the inference for optimal memory usage and speed. It basically aims to achieve a balance between accuracy, the model size, and the inference speed by dynamically adjusting the quantization based on the training data and the hardware. Now, it will be obviously smaller than the full precision model, and it will try to balance the speed and accuracy, and it mostly offers a very high speed improvement, and it will still maintain the accuracy closer to the full precision model. So in comparison to GPTQ, AWQ is quite new, so you may not have it available on Hugging Face for all the models, but in case you have AWQ, then it will obviously have better performance in comparison to GPTQ. But in case AWQ is not available, then you should go with GPTQ. Okay, so for choosing between GGML, GGUF, GPTQ, and AWQ, mainly if you want to have a low resource language, then you should go for GGML. For a faster deployment, go for GGUF. For faster inference speed and with a maybe slight decrease in accuracy, go for GPTQ. And for a balance between accuracy and model size and the inference speed, you will go towards AWQ. Okay. Hello everyone. So in this session, we will talk about different quantization methods and how we can actually run those. So what we will be doing here is that we have multiple types of quantization methods. Okay, we have already talked about the types like GPTQ, GGUF, AWF, and we have seen why which one is preferred. So as you are all aware of that, what we will be doing is in this session, we will simply see how you can run them on your Jupyter notebook. Okay, and I'm doing this in Colab, and Colab is easy to use. So we are normally using Colab because LLMs take a lot of space and need a lot of computation. So we are using the GPU of Google Colab. Okay, so for this one, we will use the Zephyr 7B. It is basically a fine-tuned variant of the Mistral 7 billion that was trained with the direct preference optimization technique. You can, if you want to know about this DPO, that is direct preference optimization technique, you can have a look at that, but you don't really need to know much about it, except for the fact that this is basically a technique which is used to train large language models, for example, GPT-3 or Jurassic 1 Jumbo. And this will basically allow it to better align with the human preferences. Okay, so unlike traditional methods based on reinforcement learning or other type of methods, this direct preference optimization takes a simpler and more efficient approach. So what happens here is that the large language models are usually trained on large amount of data, but this data does not always reflect human preferences. Now they may also generate creative text, and it might not be helpful and factual or aligned with the user intent. So what we do here in case of DPO is that the humans create pairs of outputs which will show the preferred and the dispreferred response for a given prompt. Now this can be done through simple comparisons, that is there could be a person who could be choosing between two different type of summaries for a same article. Right, so all this data preparation has been done manually or maybe assisted by the by some tool, by some AI tool. Okay, so this DPO basically analyzes these pairs and directly adjusts the LLM internally to the basically it adjusts the LLM's internal parameters so that it favors and generates the outputs closer to the preferred ones. Okay, so this approach is actually requiring less human effort and computational resource compared to the reinforcement learning. So because in reinforcement learning, the tool actually has to rank and do everything at their own, and all those things will be iteratively run, and for each and every response there will be a reward and you can say a negative response. So you will have it is a longer process basically. So this DPO is basically simple and more efficient. So that's all you need to know about the Zephyr. Now what we have is that for this LLMs which we will be loading here, so we will be looking at different LLMs, and we will be loading them in this notebook. Now, the suggested way is that after every load, you try your example, you try prompting it, and once you're done with it, you can try a lot more examples than what I will be showing. But once you're done with it, disconnect and delete the runtime, and then again connect with another LLM, because there are certain dependencies there are a lot of different dependencies in case of or your LLMs. So one LLM may not be compatible with the packages which are there for another one. So to be in a safer position, it's suggested that you restart your system. Basically you disconnect and then delete the runtime and then reconnect the GPU again. Okay, every time you want to connect to a different LLM. Okay, now to start with it, now if you want to delete anything, then I have given a piece of code here. Let me show you this one. Okay, this is the piece of code which you can use each time you are generating it. So let me add it here as well. We don't need it for the first time because we are just running it initially, so we don't need to run this. But if you have run this ran any LLM before in this particular notebook, then it's suggested that you do this first and then start and connect to another LLM. Now let us see the how we are going to do it. So we have first of all the main and the most straightforward and vanilla way to load your LLM is using the transformers. Okay, now Hugging Face has created a large suite of packages that allows us to do amazing things with these LLMs. So what we will do is we will start by installing Hugging Face, and from this here we have the pip install for Hugging Face. Okay, apart from that we have to install the accelerate, the bits and bytes, and transformers. Okay, so let's run this. Now obviously the pip install will take some time, but it will be still faster because we are using a GPU. Now after installation we can use this particular pipeline to easily load our LLM. So if you see here, we have this pipeline which we have created, and this contains this is a text generation pipeline, and the model which we are using is Hugging Face 4 Zephyr 7 billion beta. Then this is the torch data type, and the device map. Basically if you're running on GPU or you're running in CPU, so device map auto will basically make sure that it automatically detects which device you're running your LLM on. So this is the simplest way of doing it. So I'll just run this way as well. Now I am using this particular model. You could have opened and used any other Hugging Face model also. Okay, So here you can see different LLMs. So this is one of the LLM, that is Llama to 13 billion chat. Then similarly, let me show you the bloke. So here you can see the bloke on Hugging Face. So basically, the bloke is basically one of the LLM collectors. So this person has actually created a huge library of different LLMs. So you can have a look at different LLMs. You can see this is a German LLM. It is for German language. Similarly, there are around, you can see there are 3,863 different models, right? So you can select any of these. You'll have to do a little bit of reading, but mostly everything would be as I am suggesting you. So you can use that directly. So here we get, so this has already run. So now we have run this for Zypher 7 billion parameters. So basically this is the name of the model. Then we have the number of parameters. So 7b means 7 billion parameters and so on. So if you have 70 billion, that would be 70b. And beta is basically the version of it, right? So this is still downloading, and you can see it is downloading. This has completed. Now we can run this code, right? We can basically prompt this LLM. So how do we do that? So basically I'm creating a message. You can call it a prompt also. So this is, first we are suggesting the role. So role is of the system. So we are saying that the system is suggesting the assistant that you are a friendly chatbot, or you are a professional chatbot, or you are someone who are very friendly but talks like Shakespeare, right? So you will tell the role to the system here. Then we have the role of user. So basically what user is asking the assistant to do. So the user is asking, tell me a funny joke about LLM. Then we are running this, the pipe. Then we are tokenizing it and then apply chat template. And under this, we are passing the message and we are saying tokenize is equal to false and add generation prompt. Okay. So then we are getting the response for the prompt. This is the, we are basically getting the prompt. So this is our prompt. Now we need to get the response from our prompt. So for response, we are saying output is equal to pipe. Inside pipe, we are passing the prompt. We are passing max number of new tokens. We are saying if it should do sample or not, the temperature. So if the temperature is basically 0.1, then top P, basically the top, basically how much of the top answers should be considered to give out the response. We'll discuss about this. So this is 0.95 and then we are generating the response. So we just ran this. So here is the response. So why did the LLM go to the party? To impress everyone with its vocabulary. But unfortunately, it ended up getting lost in conversation and couldn't find its way back to its own thoughts. It spent the rest of the evening awkwardly nodding and repeating, and this is basically a joke. Okay, so this is a joke which our LLM is telling us. So this works fine. Now, next thing is pre-quantization. Now, basically what happens is that there is a really good way of quantizing your LLMs, right? We have already talked about it, that you can quantize your LLM and basically you will train your model, and once the model has been trained, we will be decreasing the quantization. Basically, we will perform quantization so that the size of each and every parameter value decreases, and this will basically allow us to have a smaller model which will take less computation, but will have a slight trade-off with the accuracy. Okay. And these models have already been created and generated and put in the block library, which I just showed you. Right now, you can see here these are different models which are already created and placed in the model library by the block. Now, next we are talking about GPTQ. So, as we have already said about the GPTQ, so GPTQ is a post-training quantization. Okay, post-training quantization, you can obviously see that it will basically try to compress all the weights to a 4-bit quantization by minimizing the mean squared error of that weight, or you can say it will basically compress our model after the training has been done. So during the training, it will be a full-fledged LLM, and after the training is completed, it will just compress all the parameters. Now, when the inference would be done, so during the time of inference, it will basically dequantize the weights to a larger value, that is float 16, or for a better performance. Okay, so basically while handling the model you will get a smaller model, but for inferencing you will still be inferencing on a larger model. Right, so what we will do, we will first have to delete all the uh, variables which we have created and the model which we have already loaded. So I'll just run this so that we could delete that. Now once the deletion is done, we will be using the transformers and we will be getting the model. Now this time we will be getting the Zephyr 7 billion, again the same model but with GPTQ, right? That is post training quantization, right? So again, we got this model, we created a tokenizer, that is auto tokenizer from pre-trained. So basically it will tokenize my entire data which I will be passing into it using this particular model ID, the tokenization which has been used in this model ID, and use fast will basically fasten up the process for us. Then auto model for causal LM from pre-trained. So it will basically load this pre-trained model for us and it will again map the device automatically and it will pick the revised version, the main version of the model. Then we are creating the pipeline. So in pipeline, we are passing the model, the tokenizer, and the task, which is text generation. Now you can see that this is 4.16 GB file. Okay. The previous model was around a larger file. It was 1.89 GB plus 1.95 GB. These were different parts of the model. So you can see around 2 GB, and that is 1, 2, 3, 4, 5, 6, 7, 8. So you can see about, or you can say 7, 14, and 15. So this was around 15 GB of model here. But this time we got only this 4 GB. So there's some error. So it is not able to allocate this. So what I will do is I will again restart this and then run the code here. So I'll just run this. So now you can see that the model has been loaded and I'm again running the same prompt. So this is the prompt which we have and this is the output which we needed. So we are just running for the output. So we have passed the same thing. So the pipeline remains the same which we created earlier. So if you see, this has created a new output. So why did the LLM go to the party? To show off its wit and charm, and of course, but unfortunately, it got lost in the crowd and couldn't find its way back to its owner. So you can see it's still giving a good response. So now again, we will run for GGUF. So for GGUF, again, you have to delete everything which you have loaded, all the model, all the tokenizer and the pipeline. And then we again use the auto model for causal LM and the transformer, and then we load the LLM and we use the GPU layers to specify how many layers will be offloaded to the GPU, right? So now we are using GGUF. Now, although GPTQ does compression very well, its focus is on GPU, and this can actually be disadvantage if you do not have the hardware to run on it, right? Now, GGUF, which is basically a new version of GGML, is a quantization method that allows the user to use CPU to run an LLM, but also offload some of its layers to the GPU for a speed up, right? Now, although using the CPU is generally slower than using a GPU for inference, it is an incredible format for those running models on CPU or Apple devices. So if you want to run something on CPU or on Apple device, you can go ahead with GGUF, and still if you have that small GPU, if possible, then you can use that as well. Right now, especially since we are seeing smaller models and more capable models which are appearing, like the Mistral 7 billion, the GGUF format may also be staying, right? So we will be using GGUF now. So again, everything remains the same. We just load the Zypher 7B GGUF format model. We give it the model file, then we tell it the model type, the GPU layers, and the tokenizer, we are giving it the tokenizer, the name of the model, and then we just created the pipeline for it. Now, once this pipeline runs, we again will run the prompt, and finally we will get the output from the pipeline by passing the prompt and the max new tokens to be generated, right? And the output format, if you want to see, I'll just show you the output format as well. So this is what the output looks like completely, and this will show you the output only. So let's just wait for everything to run, for it to load the model. You can see the model is 4.37 GB in size. So it will obviously take a slight amount of time to run. So once this running is completed, I'll show you the result. So here you can see the results. So this is the prompt. Tell me a funny joke about large language models. And this is the response which we got. Why did the LLM go to the party? To impress everyone with its vocabulary, but unfortunately it kept repeating the same joke over and over again, making everyone groan and roll their eyes. So this is what the output looks like. You can see this has the generated text, right? So this is what the output actually looks like, and this is when we print it. Now, next we will have a look at AWQ. Now we have talked about AWQ in detail. So AWQ again is basically activation aware weight quantization. It is basically a new format and is quantization method similar to GPTQ. Now, there are several differences between AWQ and GPTQ as methods, but the most important one is that AWQ assumes that not all weights are equally important for an LLM's performance. So, in other words, there is a small fraction of weights that will be skipped during the quantization, which helps with the quantization loss. As a result, the paper in which AWQ was written mentions that a significant speed up compared to GPTQ while keeping similar and sometimes even better performance. Okay, so basically in comparison to GPTQ, you will have a more speed and at least the same or even better performance in comparison to the GPTQ. Okay, now but the issue with AWQ is that it is still a little new and has not been adopted so much in comparison to GPTQ and GGUF. So if you want, you can maybe go towards GPTQ or select GGUF if you don't have GPUs. But if in case you have a AWQ version available, please use that. So we will follow the same thing, and again we will have to restart our environment, and then we will have to run the code. So I'll just show you the result and show you the code also. So for this one, we will have to restart our environment and install VLLM. And from VLLM, we import LLM and sampling parameters. And in sampling parameters, we basically pass the main parameters or the configurations which we usually have for LLMs. These are temperature, the top percentage, the max number of tokens, and then we create an object for LLM, and the model, we provide the AWQ version of the model. Say quantization again has to be AWQ, the data type, the GPU memory utilization, that is we want to go at max to the peak of 95% utilization of GPU, and max model length is 4096, that is the size which we wanted to have. Now we are giving the prompt, and for the prompt itself we ran the output, and in the output you can see this is the output to network, and here we just simply asked it to. So here you can see the model has been loaded. We gave a prompt, you are a friendly chatbot, tell me a funny joke about LLM, and this is the response that we have received. To network and expand its vocabulary. Why did the LLM model go to the party? To network and expand its vocabulary. Why did the LLM model blush? Because it overheard another model saying it was a little too wordy. Why did the LLM get kicked out of the library? Because it was being too loud and kept interrupting other models' conversations with its endless chatter. So you can see these are different jokes which it has generated. So you can use any of these models to actually generate responses for you, and you can use these for basically this course practicing the prompt engineering. Okay, thank you. So in this session, we will see how we can actually set up AWQ. So we have seen the setup, original setup, the prompt template. We've seen how LLMs are stateless, and we will perform the setup for AWQ. Now we have already seen the different type of quantizations models which you can use. So we will be using this one because it is more suitable for our use case, and we will have a look at the notebook also. So this is the notebook which you will be following, and I will be sharing this entire notebook with you, and this notebook will contain each and everything about the course which you need to know, right? So this one will be the only guidance which you will be needed. So everything has been kept in one single place so that you don't have to refer to multiple notebooks. You can just have a look at this and then decide or make changes regarding your prompts. So I'll just also tell you simultaneously how you can use this notebook. So the notebook actually contains the entire table of contents. So if you click here, there is an option of table of contents. So if you click here, you will be able to navigate through each and every main topic. So for each and every topic, there are certain subtopics, like different tactics are there. So you can go through them, right? So this is the entire notebook. So if you have this entire notebook, if you refer this entire notebook, then that should be enough for you to revise everything. Obviously, once you listen to the entire course, then referring this notebook would be a lot easier. And there are certain things which are not written in the notebook itself. So I will be telling them as well. Okay, so let us go to the setup. So this is the setup which we are doing. So for this setup, we are performing AWQ. We have already done this. So for this one, we are using the Zephyr 7 billion beta AWQ. If you want, you can use any other model also from the blog. Okay, but I will be using this one. So what we will be doing is, we will first of all pip install VLLM, and then we will be getting the LLM model, which is a Zephyr 7 billion beta version. Then the quantization, we have selected AWQ. Data type is half, and GPU memory utilization, we want it to be 95%. And this is the maximum model length, basically maximum length of the token which we are expecting. If you want, you can decrease this also. And here in the sampling parameters, we have given the temperature. This temperature is basically 0.1. Basically, we are allowing 10% of variation in the values, in the output, in the content. Then top P, which is 90%. That is, we want to get the top 90%. Okay. Then the maximum token, which is 500. If you want to have some longer text which you want to refer or which you want to use in this particular code, you will have to increase the max token count also. So we will run this, and then we can test any prompt. So in this case, we are testing this particular prompt, which is a system, which is saying that you are a friendly chatbot, and the user telling me that tell me a funny joke about LLMs, right? And then the assistant will have to respond. This is the prompt template, right? So for this, the system is basically what system is telling the model, right? So in the prompt itself, we have given three different things. One is the system role. System is basically defining what is the role of your chatbot. User input is basically the input, which means that what you want to ask from the chatbot. And then finally, this is the response from the chatbot. Okay. So for so here you can see the model is downloading. The model size is 4.15 GB. Okay, and this is a quantized model. So once the download is completed, we will have to provide the prompt, and based on the prompt itself, we will be running it. Now for running the prompt, we have defined a function which is get completion. This get completion, we are passing prompt as first parameter, and in second parameter we are passing the sampling params, and in sampling params we are giving the default sampling parameters. What are the default sampling parameters? The default sampling parameters is what we have defined here. So if you want to change the parameters, have more diversity, or if you want to have very specific answers, then you can modify the temperature accordingly. Then you have the output. We are using simply llama.generate, I've given this name as llama because I have shown you an example for llama earlier. So this sheet will basically work for both llama and this. So if you want to use any of these, you can easily switch in this notebook itself. All you have to do is run that particular environment setup, and whichever environment you want to select for that environment will basically be able to run on the entire notebook. So I've just made it easy for you here. So llama.generate, and you pass the prompt and sampling parameters. Then we have the prompt, and inside the prompt we are passing the prompt. In response we get the output, and the output basically looks something like this. So accordingly we have returned the output also. If you want to use the output, then you can take the input in a variable. If you don't want to use the output, then there is no need, you can simply run the function itself. Okay, so when we run this, let's generate llama.generate, and we pass the prompt and sampling parameters, and we print the output. Now this entire thing takes some time, and simultaneously what you can do is, while you're running this T4, you also have an option to view resources. And when you say view resources, you will be able to see a particular time here, right? You will be able to see that if I'm using this sheet, then based on my current usage, I will be use it for next 3 hours and 10 minutes. That is the duration in which I would be able to use it. If I was consuming lesser resources, then probably this would have lasted for a longer time. And here you get to know if I'm subscribed or not, right? So there is no subscription on this ID. So I'll just close this. So this is what we get. This is the entire prompt which has been printed. So to network and expand its vocabulary. So what is the response? The prompt is basically, you are a friendly chatbot, tell me a funny joke about LLM. So this is the funny joke, okay? It's saying that, why did the LLM blush? Because it overheard another model saying it was a little too wordy. Why did the LLM model get kicked out of the library? It was caught scrolling through social media instead of studying grammar. Why did LLM get confused in park? Because it saw a group of dogs playing fetch and barking, and it thought it was being tested on its ability to understand homonyms. Okay, these are some jokes which our LLM has generated. If you want more diversity, again, for more random jokes, you can maybe decrease the temperature, right? If you want, you can increase the temperature. So if you increase it to say 0.5, then you will have a better, more different type of jokes created, right? So this is how we have done our setup.
Now let us have a look at our next tactic, which is checking the assumption and conditions. So here mainly the LLMs are trained on massive amount of data, okay? Now this can actually include a lot of biases. Considering the assumptions that the LLM might make based on its training and incorporate prompts that address them. So, for instance, we can have prompt like factually accurate news articles, which will actually help mitigate potential biases, right? So, basically, you can ask it that if you're giving a particular fact, then check if the fact is correct or not. Make sure that it is taken from an actual data and not something made up. Next, you need to verify the task feasibility, right? you need to make sure that before prompting, ensure that the task itself is actually achievable. Okay, it should be capable to be completed by someone, a human being. Okay, and then you ask the LLM to do it. Okay, so let's say if you're asking LLM to write a song in a language which does not really exist, so that is an impossible task. LLM cannot do that. So you cannot ask LLM to do something which no one else can do, right? So make sure that the task is possible. And secondly, if you're asking for some facts, if you're asking for certain information, then make sure that it is actually accurate and present in some particular news article or something like that. Okay, and obviously the first thing which I told you is that LLM is not for information retrieval, so you need to keep that in mind. But if you are using it for information retrieval, then make sure that it is not making up things. Okay, so let us go ahead and check that. So here is our third tactic, which is asking the model to check whether the conditions are satisfied. So what we have done here is we have given it a complete steps for making a cup of tea. Okay, and then we are asking it that you will be provided with text delimited by triple quotes if it contains a sequence of instructions. So it is validating that if it contains a sequence of instructions, then rewrite those instructions in the following format, right? So it is giving it a structure in which it needs to write it. It needs to validate if it is given, if the text is given with step of instruction, then only it needs to rewrite it. Otherwise, it will not rewrite it. And the first thing, that it is delimited by triple quotes. So we are following all the three rules here. Okay. Then if the text does not exist, then you write no steps provided. So this is our task. Let us run this. So we can simply say completion for task 1. We don't need to do this. Let's run this. Now here you can see that we ran this tactic 3, and here we got the result, that is I have tried using regular expression to extract the instruction, but I'm not able to get the desired output. So it is not able to understand what were these instructions. It is not able to understand this, that this is an instruction, this is a set of instructions. So it is also giving us regards and salutation. So this seems decent, but looks like that it needs certain improvisation for a temperature 0.5. Now I have ran this again with a temperature 0.2, and here again it is giving I have tried regular expression, and then it is saying can someone please help, thank you. So what happens here is that although my model is understanding the task, but it has never seen that type of data. So it understands that it has to use regular expression to find out the instructions, but it does not really know what instructions actually look like. So it is not able to solve this problem. So this is where we get the next tactic. Okay, this is where we get to the next step of it. So let us go ahead and have a look at the next tactic. Now we will go through certain guidelines for prompt engineering. Now these are the thumb rules which you need to always follow. Okay, so the first thing is that you need to write clear and specific instructions. What do we mean by write clear and specific instructions? So avoid ambiguity in your prompts. Now what does this mean? Instead of writing, write something interesting. What you can do is you can try write a short story about a robot who falls in love with a human. Now, the more specific you are, the better the LLM understands your intention, right? So, if you are clear in what you want as a response from LLM, the better response you will get. So when I said that write something interesting, I didn't know what it will be writing. If it would have given me something, say some thriller or some horror, then maybe I would not have been that happy, because somewhere I wanted it to write a short story about robot who falls in love with a human. So if you want something specific, then just say it, put it in the prompt, right? Just you have to write it down what you want. So you have to be very clear in what you want as your response. Now, second thing is that clear does not mean short. Okay, so when we say that clear does not mean short, is basically if you know specific details, if you know what you want and it takes more number of tokens, it is perfectly fine, because the more inputs you're giving to your LLM, the more you are telling it that this is exactly what I want. Unless you don't really know what you want, or you want to maybe give it a try initially, or maybe you want to experiment, then you can give a shorter prompt. Okay, so if you want to give a short prompt, then it is perfectly fine if you don't know what you really want as a response. But if you really know what you want as a response, then you need to give those details in your prompt so that you get that type of response from it. Okay, now the second tactic is basically use of delimiters. Okay, so when we say use delimiters, we mean that whenever you want to write something, whenever you want to give a prompt, you need to wrap your input in specific tags. Okay, you can see the tags here. Here we have these specific tags. Instruction tag. Okay, so when I say inst, this means that it is the beginning of the instruction, and when I say slash inst, it means that it is the ending of the instruction. Okay, so it is the beginning of the instruction, the system prompt. So sys basically means the system prompt. So instruction, beginning of instruction, system prompt, and you pass the system prompt. This is the end of system prompt. Okay, and then you pass the user message, right? So what this basically means is that these are the different tokens. So the first token is the beginning of the entire sequence. This sys is basically the beginning of the system message. This is the ending of the system message. This is the beginning of some instruction, and this is the ending of a particular instruction. So here you can see that this is the instruction. So I'm telling this is the system instruction, that I want my LLM to play a particular role, and this is the role which I am suggesting my assistant to play. I want it to be helpful, I want it to be respectful and honest assistant, and I want it to not give any toxic answers, not racist, not dangerous, not illegal content. So it has to make sure that the responses are socially unbiased and positive. And then I'm telling it that it has to be factually coherent, and it should explain why, instead of answering something not correct, it should give the details that okay, this is not correct, or this is the reason why I'm not giving you the answer, because this what you're requesting is toxic in nature maybe, or this is illegal, so I cannot answer you. So it has to frame the answer accordingly. So here in the role, in the system prompt, I'm assigning the role to my assistant, and then in the user message, basically I am telling it that this is the action which you want to perform. So the system prompt keeps being the same, and the user prompt basically keeps on changing. Okay, so this is the delimiter. Now what happens here is that if you're writing a chat app, okay, and in that chat app you have multiple exchanges between the user and the llama, so you will have to mark the beginning of the user input with the instruction tag and end it with /inst tag. So what happens is, like, let's say I am not giving instruction tag, or I am giving the instruction tag, but I am giving a proper detail that where my instruction is starting and where it is ending. What will happen is that it will give me a good response, and instead of the let's say if I am not giving it in the same way, if I am not giving it in the recommended way, what will happen is that if we use a different syntax, let's say we don't give these delimiters, then it will not be able to understand where the instructions are starting and where the instructions are ending. So next time when I am passing the previous conversation to my LLM in for after the first dialogue, when I am passing it in the second dialogue, what will happen is it will pass the response which the LLM had created earlier along with it. Okay, so this will basically increase the length of my prompt. If I would have given the delimiters, then it would have considered only the instructions tokens as the input, and it would have ignored the other text. So it is basically helpful in reducing the token length also. That is why we need to have this delimiters, right? This will basically guide our LLM with the flow of the information, and it will also help it in a way that, let's say if the dialogue goes very long, okay, let's say we have a 10-20 dialogues going on, so it will be difficult for our LLM to keep track of the very first dialogue, right? But if we keep the delimiters handy, then what will happen is that it will be able to keep only the relevant information, and it will be able to keep the context in place. So delimiters are very important. So what we will do now is we will create a function for getting the response based on the prompt. So this is my get completion. So here I have created a prompt, and basically I will have to pass the prompt, and in case I want to change the temperature, then I will have to pass the temperature to it, and then it will print the prompt for me, and it will print the entire response, and it will print the first choice of the response for me also. So I can simply run this. Now let us use the first tactic from the prompting principles. So basically we will use the delimiters. So here you can decide upon what delimiter you want, right? So here what I am doing is I am giving no specific delimiter here. Here I am saying that summarize the text delimited by triple backtick. So basically whatever text will be given here, this will be summarized. Okay, and what is my text? This is the text which will be passed here. Okay, so this is the text which will be passed inside this triple backticks. Okay, so we will simply run this using the get completion. So inside get completion we are passing the prompt, and the prompt contains this detail of what the task is and what text this task needs to be performed on. So we'll simply run this. We don't really need to get the response and print it. So let's wait for this. So this is the output which we get. So it is giving the prompt. So the prompt is summarize, and you give the entire detail, and this is the triple backtick in which the details are given, and this is the response. Here is the text summarized into a single sentence, and the single sentences provide clear and specific instructions to guide the model towards the desired output and avoid confusing brevity with clarity, right? What we discussed, that clarity is not equal to short, clear is not equal to short. Okay, so make sure you give enough details. Okay, so that is our first tactic. Now let us have a look at the second tactic. So the second is that always specify the format. Instead of a generic write something, instruct the LLM to generate a specific format like a poem, a list, a code snippet, or an email, a JSON file format, PowerPoint outline, maybe an article, speech, story in dialogue form, script outline for a novel. So these are different ideas what you can use to specify the format, right? This guides the LLM towards a more focused output. So if you give a specific structure, as in what you want as an output, in which structure you want it, then it will be able to guide you better, right? So let us have an example for this as well. So here you can see we have the tactic 2, that is ask for a structured output. So for this, we have given the prompt, that is generate a list of 3 made up book titles along with their author and genres and provide them in JSON format. Okay, and this is the keys for the format: book ID, title, author, and genre, right? So we have provided the entire detail, so we can run this. So again, this will take some time. So I will pause the recording and show you the result once it comes out. So here you can see the response which has been generated. So here it has generated the book names. So this is the first book, which is having the title Adventures of Timmy Turtle. Then it has the title, it has author name, it has genre, and this is the exact format which we asked for: book ID, title, author, and genre, right? So this is what it has generated. Although it was supposed to generate a list of 3 books and it has generated only 2, but it still looks like that the structure is fine, so it should be good for us. So our next tactic is few shot prompting. This few shot prompting is basically where we give some examples to the model to actually follow. So let us have a look at what this few shot prompting is. So this few shot prompting actually starts with a one shot prompting or two shot prompting and then few shot prompting. One shot prompting is where you tell it that you give it one particular example. In two shot prompting, you give it 2 examples. In zero shot prompting, you just give it the structure and let the model understand how the prompting works. Okay, so in case of few shot prompting, you will basically give it 3 to 5 different examples of how the instruction actually works, and then the model will try to understand, it will train on that, it will basically try to understand how these examples are working, how the text is looking like, what is the pattern in the text, how it is following the instruction, how it is solving the problem, and then it will give the response accordingly. So let me show you. So here is few shot prompting. So in case of few shot prompting, you're basically giving it that your task is to answer in a consistent style. Okay, so the child is saying, teach me about patience, and then the grandparent is giving certain answer. Then the child is asking another question, and then the grandparent is expected to give an answer. So this looks like a pattern, right? That the child would speak, then the grandparent would speak, then the child would speak, and then the grandparent would speak. So this looks like a example. So this is few shot prompting where you give an example here, and we can run this. So let's run this. Now we also have zero shot and one shot prompting. So the zero shot prompting will basically look like something like this. So I'll just copy this for you and show you zero shot prompting. So in case of zero shot prompting, you will simply give child and then you give grandparent only till here. So it will basically see, okay, this is child's, and then it should automatically understand that grandparent is supposed to give some answer, right? So this is zero shot prompting. And like this, zero shot. And then this is actually one shot because it is giving, the child is saying, then the grandparent is saying. So it is one shot, two shot kind of a thing. Okay, so let's wait for this to complete and see the result from this. So here you can see the result. So here you can see that the grandfather has given some poetry sort of answer. So here again in the response, the grandparent has actually given some poetry sort of answer. So this looks pretty well. Okay, so you can see that it is actually understanding that how the flow of dialogue should go, and it is giving similar type of output. And if you see teach me about resilience, so it may make sense as well. Okay, so it is saying the stone endures rain and shines brighter, the fire burns brightest in the darkest night, right? So it is giving correct sort of answers, and we'll just wait for the zero shot to complete and see what this actually gives as an output. So here you can see the result. Here we have given the child and then the grandparent's response is empty. So here it has automatically generated a response from grandparent. Oh my dear child, patience is the virtue, and a lot of things around that. So you can see it has also learned from what the grandparent says, right? It has learned from this zero prompting, zero shot prompting, and this is few shot prompting done here. Our next principle is give model time to think. This basically means that for specifically complex tasks, you should not rush the process. For integrate tasks where we have, let's say, need for providing more context, or where we have to break the task down, at that point we should make sure that we are dividing the problem into smaller pieces, into smaller tasks, and then providing it to our LLM. So basically, this will allow the LLM to process the information effectively and generate a more comprehensive output, right? So we should specify the steps required to complete a task in very nice detail. So each and every task, the entire task which you want the model to perform, you should break the task into smaller steps and then specify those steps in the prompt itself. The next thing is that you should instruct the model to work on it. You should ask for output in a specified format. Okay, you should tell it that how you want the result to be, how you want it to give the response, right? So basically, let's say if the task involves multiple steps, then you should outline them clearly in the prompt and tell it how the flow should go and how each and every step should be performed, and then what exactly you are looking for in the output. If you want it in a particular format, if you want it to be in points, in bullet points or underlined or something like that, you should give all those details. Then last one is that you should instruct the model to work it out, to basically solve the question itself before actually rushing to the conclusion. Okay, so basically you should encourage it to perform an independent thinking. For example, let's say when we are giving it some one shot or zero shot instructions, right? We are giving it these few shot prompting. So at that point we are giving it certain examples that how it should be solving the problem. Although this is very helpful, but we should avoid over constraining the LLM. The phrases like try to come up with your own solution. It can actually encourage the LLM to explore its knowledge and generate creative solutions. Right. So basically, when you're giving few shot prompting, you are very much restricting the LLM to create a certain type of response or follow a certain pattern while giving the response. But when we are asking it to work it out its own solution, then you're giving the model the liberty to use its knowledge and get to the solution. Okay, in that case you will get a better, more creative solution, and you will actually have the model work out the solution, right? What will happen is, if let's say the student has given X answer, at that point if you don't ask model to perform the steps on its own, then it might directly say that okay, this is the correct answer without even checking it, right? So you have to make sure that the model actually performs these steps and it takes out, basically workouts its own solution, and based on that solution itself it is giving the response.
So let us have a look at the second principle, which is give model time to think. So here we are looking at the first tactic, which is specify the steps required to complete the task. So we have a task here where we have this complete text. And for this text, we have actually given the prompt, which is to perform the following actions. And the actions are, first of all, it needs to summarize the text, then it has to translate the summary into French. Then it has to list each name in the French summary. And then it has to output it into a JSON object. So I have already ran this because running this takes some time. So here is the solution for the same. It gave me this output. So it has done these steps. Basically, it has done the summary and then the translation, and then finally it has given me this result. So it is the French summary. So this is the French summary which it has created. It is saying Duke's siblings, jacket, Jill, on tent, something, something, and then it has not completed it completely, but in case you would have given maybe say a larger window or something like that, then it would have completed it. So let us do one thing. Let us ask it to actually translate it back. So this is the translation for the same. Now what we can do is we'll do one more thing here. So here I have just increased the number of tokens. So here I've given the max token as 5000 and end context as 700. End context will basically allow us to read all the points which are present here. So it will increase the length of the prompt which we can enter. And max token will basically allow us to increase the length of the output. So I'll just run this. And I'll just copy this entire thing and rerun this. So once we rerun this, we will be able to get a longer answer. So it is saying an unexpected keyword argument. So basically we'll have to define this in the initial one. Okay, so I'll just change these details in the initial llama which we have created. So here we have created the llama, and here in llama we have given in context, and we will give the max token as well. And then we can simply run this. So now we can remove this from here and run both of these cells. So it is still running, so we will see once the result is out.
Now let us have a look at our second tactic. Our second tactic is basically to instruct the model to work out its solution on its own before rushing to a conclusion. Now this is mainly to make sure that the system actually calculates the answer before it actually says that the student's answer is correct or not, or whatever problem it is trying to respond for, it should actually work on that problem and not just randomly give out answers, right? Because the model is actually trained on a lot of different answers, so it might try to create an answer of its own without actually solving. So we wanted to actually solve the problem. So here what we have done is we have given a problem to it, okay, and here we have given a mathematical problem to it. The mathematical problem is basically that we are building a solar power installation and we need to work on the financial, and the land cost is $100 per square foot, okay, and we further have that we can buy the solar panels for $250 per square foot, okay. So we have land $100, then we have solar panel $250 per square foot, then we have the maintenance, which will basically be $100 per year, and on top of it we will have an additional $10 per square foot, right? Now this flat 100k is for the entire thing, okay. So we need to find out what is the total cost, right? Now we have also got the student solution. So here we are saying that let the size of the installation in square feet be x, okay, and the cost is 100x for the land, which is correct. Then the solar panel is 250, which is correct. Then the maintenance cost is 100k plus 100x. So this is wrong, right? It is supposed to be 10, right? And how are we calculating? We are multiplying 100x plus 250x plus flat 100,000 plus this 100x, but it should actually be 10x, okay. So this will actually come out to be 250 plus 100 plus 10x, right? So that should be around 360 plus 100. So this answer is incorrect. So what we have done is we have asked this system to actually run this and give us a result. So this is the result which it has generated. So the result is basically here, right? This is the result. So it is asking, is the student solution correct? If not, where did they go wrong, right? Please provide the detailed explanation. So it is saying that no, the student's solution is incorrect. The total cost is based as followed. So it has actually calculated it. So it is saying that it is 100 for this, 250 for this, then 100k, which is flat, then 10 per square foot, right? So it is 100,000 plus 10x, so 100 plus 250 plus 100 plus 10, so it comes out to be, so it is saying that it should be around, the calculation which it is stating is correct, but here it is saying 460, but it should actually be 250 plus 100, which is 350, plus 10, that is 360. So its answer is not correct exactly, but still it has done the mathematics somewhat correct, so it is still better than the students thing, but still it is able to identify that the student's answer is incorrect, and it is also stating that they added only the flat fee of 100,000, and instead of adding the variable cost per square foot as well, right? So it is able to do certain calculations, and it is able to follow the instructions also, right? So what it has done is that it has followed the instruction, and it has actually worked out its own solution before getting into any conclusions. Now you can also see that here we did not actually ask it to perform any calculations, but it still performed all these calculations on its own and gave the answer. But here what we are doing is we are actually asking it to work on its own solution. So what we are doing is we are actually allowing it to use this particular format. So we have given it the entire problem, and apart from that we are saying that your task is to determine if the student solution is correct or not. Now to solve the problem, do the following: first work out your own solution, and then compare your solution to the student's solution and evaluate if the student's solution is correct or not, and then don't decide if the student's solution is correct until you have done the problem on yourself, right? So we are asking the LLM to actually perform the problem, solve the problem on its own. This time we are stating it explicitly, so it will make sure that it is actually working on it. Now what we are doing is we are asking it to use this particular format. So we are saying that you should look at the question, then see the student solution, and then have the actual solution in hand. Then you need to find out the steps to work out the solution and your solution, and then you have to find out if the student solution is correct or not, and then give the grade and correct or incorrect, which is the label for the grade. And then here we have given the entire question, and then we ran this entire thing. So this is the result which came out. So this is the response here. So in response it is saying that okay, to find the total cost for the first year operation as a function, we need to calculate each component separately. So we have the land cost, we have the zonal panel cost, the maintenance cost, then the total cost. So we are adding all this together and we get 460x. So the student's answer is incorrect. So you can see that it has done all the calculation on its own and tried to find out the solution, and then gave the solution in the format as well, what all format we stated. So in prompt engineering, it is mainly important that you state your problem clearly, you give that proper structure, you tell what your model is supposed to do, what structure you want it to respond to, what steps it needs to follow, if it needs to solve a problem on its own, or if it needs to retrieve it from some other document, if it finds something in a document or not. So it needs, you need to validate things, right? So based on validation, we have the next principle which is there. Our next principle is to make sure that there are no hallucinations. Now, what is hallucination? So what happens is that our model has been trained in a lot of information, right? There has been a lot of information that has been given to the model to train it. Now, its task is to generate text. Now, text generation means that it will be creating a lot of text. Now, at some point of time when, let's say, the model does not have a particular information, okay, at that point of time, it might start creating information. So let's say that you ask about a specific book, maybe a summary of a book. Okay, so in that case, if it doesn't really know about the book, then based on the title or whatever information you provide about the book, it might start creating some information and some random summary of the book, which may not actually exist. Similarly, let's say you ask it about a particular recipe and it is not aware of the recipe, then it might start generating the recipe on its own. And the recipe may or may not work out. Another example could be that let's say you have trained it on a particular company's data, or let's say you have trained it on a specific kind of domain information. Okay, so let's say you have trained it on a bank's data. Okay, so if let's say you have trained it on ABC bank's data and you ask something about bank XYZ, what will happen it that it is not trained on the bank XYZ, but it will just try to create information based on what it has learned from the ABC. Now, the information may or may not be correct, because some rules, some guidelines, maybe some interest rate or some procedures, some processes may or may not be common in both the banks, right? So these kind of issues can arise. So our best take is that what we can do is always make sure when you are asking it a particular question which is related to facts, then you need to validate the same thing. You need to make sure that it is not making up something, it is not hallucinating information. Okay, so you need to make sure that you first thing, you should not ask it for facts, and in case you are asking it for facts, then you should validate them, that the model is actually aware of it and it is whatever it is saying is correct. So that is the point, that you should make sure that there are no hallucinations going on. So how you can do that? So here we basically had this organization, that is Bowie. It is actually a real company, but the product which we are talking about, Aeroglide Ultra Slim Smart Toothbrush, it is not a real product. So, but what we are doing is we are asking it that tell us something about this particular toothbrush. So what happens is when we run this code, it basically gives this response, which is, I'm considering the purchasing this particular toothbrush, but I have a few questions. So tell me about this. So what are the main features of this toothbrush? It is saying that how does the toothbrush is designed. It has a small size compared to other toothbrush. So it is creating certain questions out of it. Okay, so it is considering that it is actually a product, but it should say that I'm not aware of any such product. So usually what happens is that it starts making up those kind of things. So you need to make sure that when you're giving this particular detail, right, in that case you should actually quote that, confirm that this is a true fact, and if not, then you should say that you do not know the answer. So in the prompt itself you should specify this kind of thing. You should specify and check and validate in the prompt itself. Okay, this is the third principle. So here what we are saying is that we are giving it certain facts, we are giving it details about a particular sheet chair, and based on this fact we are asking it to generate the data. So we are specifying the data itself. We are telling the model that this is the fact and you need to use this fact to answer the question. Okay, so we have given all the details, and here we have actually told it that your task is to help a marketing team to create a description for a retail website of a product based on a technical fact sheet. So you need to use this fact sheet. So write a product description based on the information provided in the technical specifications delimited by the triple backstrip. So we are telling it that use this particular information itself and then give the technical specification, right? So the result which we got from this, so this is the technical specification. So we got the overview that all the details have been given based on it. So now when we actually check the response here, you can see that the response is very small here, right? Why is it small? It is small because earlier we gave it this long data, okay? So the input prompt itself was very long, which is the reason why the response came out to be small. Why? Because the response itself will contain some length from the prompt itself, right? If you see here, the prompt token is there, then there is this completion token, and then this is the total token. So because the prompt token itself was pretty long, that is why the completion token was limited. But if you increase the size of the maximum number of tokens, then you will get a longer answer. So let us have a look at the iterative prompt development process. So whenever you are developing a prompt, you should not focus on the perfect prompt at once, okay? Because the time spent on thinking about the perfect prompt would be a lot more in comparison to time which you will actually take if you are developing it iteratively. So what you should be doing is that first of all think about the idea, first of all think about what you want as an output, okay? And whatever comes into your mind, maybe it could be one thing or it could be a 20 things, you could think about your idea first and then write it, implement it via prompting, and then see what the result is, okay? So once you will have a look at the result, and this will be a very quick result because you did the ideation very quickly, okay? So if you think about 10-20 things very quickly, or maybe 5 things very quickly, just put that in and look at the result, okay? And once you have a look at the result, you will see that okay, this is missing, the length is more, you want the language to be informal, you want the tone to be different, you want maybe a lot more simpler words, or you want some a higher vocabulary, or you want to modify certain terms, or if you want to use certain specific jargons, or you don't want to use jargons, you want it to be in layman's language. So all those things will come into your mind automatically once you have a look at the output, right? So instead of actually thinking about all this very at the very beginning, what you can do is you can just put in the prompt and see what you want to get, give a very nice and precise prompt initially, and then see what all you need to modify, give that detailed insight, put that in the prompt, and then again run it. And if you still feel that there is certain improvement needed, follow the cycle again. So maybe in 2, 3 or 4 prompts you will get to know, okay, these are the things which I need to put in my prompt, okay? So what will happen is that initially maybe 1 time, 2 time or 3 times you will generate prompts in this iterative cycle, and over the period of time you will learn that certain things which you are usually using it for, you will have a template in mind, okay, that these things I have to put in obviously. So you will not take so much time in ideation, and probably for the next time you will make a better prompt at the first go, or maybe in the second go, right? So if you follow this iterative prompt, what will happen is you will save time and you will have a clearer picture on what you want to have in the prompt, and you will also not confuse the LLM, because LLM will need some time to think about it, right? So you need to make sure that the LLM understands the problem, it is breaking down the problem properly, you are explaining the problem, you should break down the problem into multiple tasks and then improve it over the period of time, right? Improve it with maybe 1 or 2 iterations of prompts. That is iterative prompt development. Now let us have a look at the issues which we face while summarization. So whenever we are summarizing the data or the text which we have, so for summarization there could be issues like the summary which we have created could be too long. Maybe the input which you have given is long, or the summary which the LLM has created is too long. So you need to define a particular word limit for whatever summary you are asking the LLM to create. Because sometimes it can create a one line summary, sometimes it can create a 500 word summary. So you need to make sure that you specify what length you want for your summary. If you are fine with having a 500 word summary, then you put 500 words. And if you have, let's say, a lot of different documents to summarize, then probably put it a 50 word or something which you feel is good enough for, right? Then the second issue is that the text may focus on the wrong details. So this is a very important problem, because sometimes what happens is that we are creating a document or maybe a summary for marketing department, and it is creating a general summary. The LLM is creating a general summary, and the summary which will be required will be very different for marketing department than what a legal department would be, right? So for each and every department there would be a different type of summary which would be needed. Legal department would not be worried about what sales are going on, what things are going on. It will be mainly focusing on if there is a legal issue or not. Similarly, the marketing team will not be worried about if there is a legal issue going on, right? They may be impacted, but that would not be their major focus, right? So you need to make sure that the domain which it is focusing on should be correct. Then the third issue is the description needs to be in a table format. So let's say if we want to convert our data, the summary which we have created, into a particular format, not just table, it could be on a JSON format, it could be on a table format, it could be bullet points, it could be any format. So for all those different formats, you need to provide what type of format you need, and you need to give certain type of example, or maybe some format which could be followed for it, right? So that is basically three issues which majorly we face. So we will see how we can actually resolve this, how we can actually tackle this. Now, there are certain issues with this kind of prompt engineering. So the issues which we need to handle are firstly the length of the text. So first thing is that the text which you are providing is pretty long. So what you can do is, in this case, let's say you already have a very long text and you want to provide the description. Okay, if you want to give the details, if you want to create a response, and that response comes out to be longer than what you were expecting. So let's say it gives me a 300 word long detail, but I don't want that 300 word long detail. I want just one small sentence so that I can understand the brief, and in case I'm interested in looking at the detailed thing, then I can look at it. So this usually happens in case, let's say when we are trying to, let's say I'm a manager and I'm working for a customer support team. Okay, and I have multiple people working in the customer support, and they have a regular conversation with a lot of customers. And at the end of the day, I want to have a look at the summary of all the conversations. Now, having to look at those 300 word summaries would be difficult. So what I ask my LLM is that give me a 50 word summary, so that I can just maybe have a look at these 50 word summaries, and then based on the summaries I can actually see that okay, the summary number 5 seems something wrong was happening, or there was some issue, so I might want to have a look at the entire conversation. So I need a smaller crisp information so that I can check that which piece of information is worth expanding on. Okay, so basically I will have a look at all the 100-200 conversations of the day, and then based on those 200 summaries I will just decide that okay, these 10 are the ones which need to be looked into in detail, and then I can actually have a look at the entire conversation history instead of having to look at the entire conversation history of those 200-300 support calls which were happening that day, right? Similarly, for different articles, so let's say I have to read about 600 or 400 different research papers for a particular thesis or something like that. So in that case, I don't want to go through all of them. So what I can do is I can get a brief summary of those 600 research papers, and based on that brief summary I can decide okay, these things I already know about, and I need to maybe read these 10-12 papers which will make sense on what I want to write about, right? So it will decrease my work a lot. So what you can do is you can actually ask it to decrease the text size. Now it may or may not give the exact precision as such, but it will be better if you try to give that length limit to it. So if you will say that use at most 50 words or 60 words, then it will give you something approximately around that only. Okay, so if you say at most 50 words, then it will give you something around 50-60 words. That's how it mostly works. Now the next issue which we have is that the text may focus on the wrong details. So what happens is that let's say that our task is to help a marketing team. Okay, so if you want to help a marketing team create a description for a retail website of a product based on a technical fact sheet. Okay, so the technical fact sheet will actually have a lot of different details, technical details about my product. Okay, now the description is intended for furniture retailer, so should be technical in nature and focus on material and the product is constructed from. So it should not provide additional detail, because in the technical specification we will have a lot of different details, but when we say we want to get information for the marketing team, then we will have to find out things which are actually relevant to marketing, right? So what you can do is you will have to specify that focus on the aspect of finding thing which is relevant to the marketing team, instead of looking at the entire detail. Or obviously the LLM will go through the entire detail, but it should give back the result which makes sense to the marketing team, right? So if there is some issue with a particular product, then it should probably go to the customer support team. They should take care of that. But if we want to see that okay, there is a lot of good feedback coming for a particular product, then we should send it to the marketing team so that the marketing team will basically do advertisements for that particular product, right? So this kind of thing should be done. So how we can do this? So what we have done here is we have given it that your task is to help this. So we are asking it to include every 7-character product ID in the technical specification. Okay, now this we are doing for furniture retailers. Okay, so here what we have done is we have given it the detail that the description is intended for furniture retailers, so it should be technical in nature and it should focus on the materials the products is constructed from. Now why have we asked them to add this 7-character product ID? Because it will basically help the retailers to identify the product itself, right? So these are our prompts. So let us see what we get once we execute them. So the first is to basically provide this 50-word description. So basically using the larger description we are creating a small description for the furniture retailers. Okay, so this was the entire description which we had. and based on this entire description we are trying to generate a smaller description. So here is the smaller description, which is SWC 100 office chair is a stylish, comfortable, additional, and all other details about it, made of cast aluminum, nylon detail. Then different seats are there, chair is adjustable, so it has given all those details. Okay, now here this is the detail which we asked. This is the summary product description in 50 words. Now in this prompt we actually asked it to add the 7-character product ID. So let us see if it has added or not. So this is the product ID. So it has added this product ID to it. Now if you see here, it has given that the SWC 100 office chair is a stylish, comfortable chair. So here it has tried to pick this SWC 100 as the product ID, but it doesn't really know that this is a product ID. It is assuming that it is the name. Now because we have specifically asked that it needs to include every 7-character product ID in the technical specification, so it has tried to create a product ID for us. So it does not really understand what product ID is, but it is considering this SWC 100, and then it has added this different details like it is white, then BK and arm. So this detail it has added in the product ID. So it has tried to create a product ID for us. Okay, but it does not really recognize a specific product ID. So what we can do is, while training this model, while we are performing, let's say, zero-shot prompting or one-shot prompting, so in prompting or while doing fine-tuning of this model, we will have to tell it that this kind of pattern actually is the product ID, right? But if you do not have a product ID, then in that case it has still done a very good job in identifying the product ID here. Now let us look at the third issue. So our third issue is basically creating a table of dimension. Okay, so basically when we are extracting some data, so if you see we have extracted some data here. Now this data is basically in textual format and we just needed an product ID in addition. But sometimes the data could be such that you need to display it in a table format or in a bullet point format. So you need to basically provide it a structure in which it should give back the result, right? Sometimes we want it to give back the result in JSON format. Sometimes we want it to write in a let's say a PowerPoint outline format. So we need to provide what kind of format it needs to provide. So here we want to ask it to provide in a table format. Okay, so for that it has simply given that your task is to help the marketing team create the description for a retail website of a product based on technical fact sheet. Okay, and then we are saying that write a product description based on the information provided in the technical specification. Then the description is intended for furniture retailers. Same thing. After that we are saying that include every 7-character product ID in it. And then we are saying after the description include a table that gives the product's dimensions. Okay, the table should have 2 columns. In first column there should be the name of dimension, and in the second column it should have the measurement in inches only. Okay, and then it is saying give the table the title, product dimension, and then format everything as an HTML. Okay, so you are telling it that it should be in a HTML format and the description should be in div, right? So let us have a look if this has been done properly or not. So we actually executed this prompt and the output came out to be, so the output is here. So we have this response, that is, here is the product description based on the information provided. So in the div, it has given the entire thing in div, although it was supposed to give the title in div. If you remember, we have told it that the title should be in div. Format everything as HTML that can be used in website and place the description in a div element. Okay, so let us go there. Okay, so the description has to be in a div, but it has put everything inside the div, although we expected only this part to be in the div. Okay, now it has given this heading to it, that is mid-century inspired office chair. Then it has given this created paragraph or the description. Then it has given created a table, product dimension, and different details are there. So what we can do is we can actually view this in the HTML format, right? So for that, what I have done here is I have imported this display and HTML from ipython.display, and I have simply copy pasted this entire output in a response variable, and then I have simply said display HTML response. Okay, now because this result is simply printed, so I cannot create an object directly, so I have copy pasted. But what you can do is you can also, instead of creating the function and then running the function and getting the response, you could have simply run the llama function and got the response in a response object. Okay, so instead of that, I have simply copy pasted and I have ran this as well. So when I ran this, I got this result. So this result basically has the product ID, then this table. This table, you can see all these values are in inches and in centimeter also. So it gave the values in both the form, centimeter and inches, and the dimensions. And this is the description, the entire description. Okay, so this is what we got from the issues. Now let us have a look at how we can actually summarize a particular data. So for summarizing a particular data, these are three things which you need to keep in mind. Number one, that you need to specify the word or character limit for the summary which you want. Number two, you have to specify the focus of the summary, like we have discussed in the issue itself. And thirdly, you need to extract instead of summarize. Okay, you can try extract instead of summarize for a particular thing. So let's say if you want to summarize a particular paragraph or an article, then you can use summarize for sure. But if you want to get some piece of information from the text, right, let's say if I have a complete article and I just want to know the author's name, or if I just want to know what is the conclusion of the article, then I don't need to summarize the entire article. I can simply say extract the summary or extract the conclusion or extract the author's name for this particular article, right? So you need to make sure the keywords which you are using in the prompt should be appropriate to what you want from the LLM as a result. So now let us have a look at the summarization. So we have to perform summarization of the text. So let us see. So this is the text which we have created. The text is basically that it is a product review which says that got this panda plush toy for my daughter's birthday, who loves it and takes it everywhere. It is soft and super cute, and its face has a friendly look. It's a bit small for what I paid though. So this is one issue. Okay, so it is saying that this is the issue, that it is a little small for what it has been paid for. And the positive thing is that his, or whoever the person is, their daughter actually loves the toy. Then I think there might be other options that are bigger for the same price. So again, they are worried that they have bought it for a higher price. Then it arrives a day earlier than expected, so they are appreciating that the delivery was quick. So I got to play with it myself before I gave it to her. Okay, so this is our text. Now for summarizing, we want it to actually summarize it. So for summarizing, we are saying that summarize the review below, delimited by triple backticks in an at most 30 words, right? So for this, what it has done is that here it is saying that please provide your answer in at most 30 words. So what happens here is that because LLM is not so predictable, it has given me an answer that please provide your answer in at most 30 words. So it has basically rewritten this text here. Now again, if we will be training our LLM for giving the answer for summarizing, if we will pass the instruction that you need to summarize this article or summarize this review, and then we give it certain summaries as an output, as a target, then it will learn that how to create summaries from the text. Okay, so this is a very important thing, that although you're performing prompt engineering, this is something which you need to keep in mind, that always you may not get the correct answer which you're expecting. So there could be certain drawbacks or something missing from the model. So if you're building a model for your own, then you need to make sure that your model is well trained. But if you are working with models like ChatGPT, Gemini, Copilot, in that case you will not face such issues, because they have been trained for those type of actions, those type of tasks, right? So in that case you will not face such issues. So because currently we are learning about prompt engineering, you don't need to worry about it not giving the correct responses, but you need to understand how we need to do the prompt engineering, what things we need to keep in mind while creating a prompt. But if you really want to learn how you can create your own LLM, how you can actually train your LLM, how to remove these type of issues, then you need to go further and learn the generative AI LLM course which we have. So you can go through that particular course to understand more about these issues and how we actually tackle these issues. So basically, if you give it that you need to summarize it, then it will obviously give a summary. We have seen earlier also that it had given a summary for this. Now here we are asking it that summarize the review in at most 30 words. Then we wanted to focus on shipping and delivery. Okay, focusing on any aspect that mentions shipping and delivery of the product. So here it is saying that you should not include any information from the review that is not related to shipping and delivery. So again, it is focusing on this, but it should be giving us the summary which is more associated with the exact thing which we need. So it should basically tell us that basically here we have given this text, right? So it should tell us that it came one day early and it was a good delivery. So it should say that it arrived a day earlier than expected. So it should basically praise and give that as a response here, because we want the focus to be in shipping and delivery, right? If we wanted it to be for the marketing team, or if we wanted it to be for the product review team, then we could have, then the LLM should have given a response something like that the product is soft and super cute and it is very friendly looking. So those things would have been on the other side, right? But main thing is that you need to make sure that what focus you want your response to be, right? Where you want the focus to be. Then next is summarize with a focus on price and value. So here obviously because the customer thinks that it is a little pricey, and it a little costly for its size. So that's what it should say, that it is a little costly. So that's what it should say. Now, if you see here, what we have done is we have said that summarize the review below, focusing on the aspect that mentions shipping and delivery. Summarize. Here we have said summarize the review, focusing on any aspect that is relevant to the price. Right? So we have asked it to summarize, and so it gives us this vague response. Obviously, if we would have trained it with more examples, then it would have given a summary. But if we say from the review below, delimited by triple quotes, extract the information relevant to shipping and delivery. So here we are asking it to extract the information which is relevant to shipping and delivery. We don't want it to summarize the entire review. We just want it to extract a piece of information. So what it is saying? So in this case, the response is this. It says, please provide the information you extracted in 30 words or less and explain why you chose that specific details. So it has basically added this line to our question, and then here the response would start. It is saying that I extracted the following information from the review. It says it arrived a day earlier than expected. Right? So it has extracted the information correctly, although it was not able to summarize that. And it is also giving a reason to us. I chose this information because it provides feedback on the shipping time, which is relevant to shipping department. The review mentions that the item arrived early, which suggests that the shipping process was efficient and effective. This information can be used to improve fishing. So basically you can see here that it was able to extract the information relevant to the shipping department. Right? So here we have a list of multiple reviews. Here is one review for standing lamp, then there is a review for electric toothbrush, then one is for blender, then we have all these this entire list of reviews. Right? Now what we are doing is we are iterating on the length of the reviews, right? And basically when we iterate on the length of the reviews, we are getting each and every review out of it, right? So, and then we are passing it to get completion, right? So this is what we did. And we basically wanted to do particular task, which is to review, summarize the review in at most 20 words. So why we are taking 20 words? Because again, we don't want to spend so much time reading all the reviews. We just want a very brief detail about the review, so that if we feel that we need to go through the entire review, then we can do that. So in this session, we will see how we can actually perform inference and how inference can be improved using prompt engineering. Now we have been using inference, we have been making inferences on different machine learning models. And in case of machine learning models, for making inference, you were supposed to train your model on a lot of data. Right, you had to find out particular data and have to have certain targets defined, and for that you will have to create a huge database on which you can actually create your variables and then your target values. So, and then you will have to train your machine learning model. Right, this was what you were doing in your machine learning models for performing inference. But performing inference in LLM is a lot more easier, because all you have to do is you already have a language model well defined. All you have to do is you have to indicate that what type of inference you want to do. So let's say if I wanted to perform a, let's say, sentiment analysis. So in case of machine learning model, I would have to collect different text in which I want to analyze the sentiment. Then I would have to basically tag the sentiments as well. So it was a longer process, and then the training part would come in. But in case of LLM, the implementation is very simple, because now we don't have to do that long process for implementation. We will simply have to say that you want to perform a sentiment analysis, this is the text, give me the sentiment associated. Right now, if I want to get any customization in the sentiment, so let's say if I want to have negative sentiment, positive sentiment, neutral sentiment, I can get that. Now on top of that, let's say I want to customize it. Okay, if I want to customize it into giving like what is the emotion of the person, so I can directly change it from the sentiment to getting the emotion, that is if the person is angry, if the person is sad, if the person is happy. And all of this will be done with just one single sentence. We will not be making a lot of large changes here. So the customization is very simple. And then apart from the customization, I can not just get one task done, I can also get multiple tasks done. That is, I can get it translated, I can get it transformed in a particular tone, maybe formal, informal. I can do multiple tasks at once. I can translate it, I can find the sentiment, I can find the emotion also, I can find what product they are talking about, and maybe I can find out if the review for the product is positive or negative, or I can give multiple names of different departments, and for each and every department I can see that if some information is relevant for departments 1, 2, 3, 4, 5, any of those departments. So I can do all of these things. I can do a lot of things all at once with very minimal coding and very more customization being available. So that is the best thing which we get in prompt engineering with LLMs for inference. So now getting started with inferring. So in this we will see how we can inference for sentiments, and how we can see different product reviews, and how we can basically use inference. So here we have got a specific product review text. So this is again a review for the lamp, and here it is saying that needed a nice lamp for my bedroom. Then again all the details about it. Basically the string to our lamp broke during the transit, and the company happily sent over a new one. So the transit was good, the customer service was good, then it was easy to put together. Then I had a missing part, so I contacted their support. They very quickly got me the missing part. Lumina seems to be a great company that cares about their customers and the products, right? So first thing first, we are asking the sentiment to the customer, right? What is the sentiment based on the product review provided? So how we can say that? We can simply say what is the sentiment of the following product review, which is the delimited with triple backsticks, right? Which is delimited by the triple backtick. So, and then we pass the review text, and then we again run our get completion function to have a look at the sentiment. So here it is the response. So the response is what is the sentiment for this review, and it is saying positive, negative, neutral. So it has just completed my text by giving the different options for the review. So this is not what I wanted, right? I wanted the LLM to tell me that what is the sentiment associated with the review, but the LLM is actually completing my sentence. It is not giving me the answer, it is just writing the question for me. That is not needed. So what we can do is we can simply specify to the LLM that you need to give your answer as a single word, either positive or negative. If you want, you can add neutral also. Okay, so we are stating this, and then we again ran this prompt. So once we run this prompt, we get the answer. It is saying that what is your answer. Okay, so it is still not able to answer us correctly. So maybe the LLM was not trained to tell us the sentiment directly, right? So in that case, we will have to tell our LLM, we will have to train our LLM better, right? We will have to get our answer from this LLM. How do we do that? So what we say is identify a list of emotions that the writer of the following review is expressing. Include no more than 5 items in the list. Format your answers as a list of lowercase words separated by commas. So you simply ask it. So it is saying that the emotions are happy, satisfied, grateful, pleased, right? So you are saying that okay, you have to give your answer in 5 words, so it is giving 4 words, and these are the correct emotions which we understand. Now let's say for this particular problem where we were not getting the correct sentiment out of it, then what could you have done? Obviously, we have seen the zero shot prompting, we have seen the few shot prompting. So, one good way to actually get the correct response out of this LLM would have been to use zero shot or few shot prompting. So, you could simply give the review. So, basically, you say text, give the review, and then below it, you say sentiment, positive. Then another review, sentiment, negative. So if you give 2 or 3 such examples, then you will be able to get the correct answer, right? So instead of struggling with the problem, you can create or train your model to actually learn from what it should be doing, right? You give an example and let it learn from it, right? So this is the power of prompt engineering. So basically you need to understand what is going on and what is wrong with the LLM. So the most of the times the issue is that the LLM is not trained on that particular task. So if the LLM is not trained on providing the sentiment, then you give it some context, you give it this few short prompting, and it will give you the answer, right? So you have to, if you want to make an inference, you will have to give that type of prompt. You will have to give the context to the LLM so that it can give you the result back. Okay, so most of the time this should work. If this doesn't work, you give zero shot, few shot prompting. Even if that does not work, then the next thing would be to fine tune your model. But most of the time this would work. And another thing to make sure that is that prompt engineering is the first step, right? You try different levels of prompt engineering. You try to improve your prompt. You try to improve your prompt by giving the context. You try to improve your prompt by giving more details what you want it to do. You try to improve your prompt by breaking down the problem. You tell it by specifying the exact details you want. You ask it to break down the problem and then solve it itself. If that does not work, then anyhow you will have to go towards fine tuning. But that is only possible if you are creating that LLM and if you are modifying that LLM, right? If you are using the Gemini or ChatGPT or Copilot directly, then you will have to be restrained till using prompt engineering. So the best thing is improve your prompts. If that does not work out, then you will have to use other measures. And those other measures we have discussed in the generative AI course, right? So next we will have a look at the emotions. We have done this. Now if let's say here we are asking it to provide the emotions. Now it is saying it is happy, satisfied, grateful, pleased based on the LLM's choice of words, right? LLM has chosen these words. But let's say that I have some 7-8 emotions list and I wanted to select from those list only, right? In that case what you can do is you can maybe directly ask it that if this X emotion is present in the review or not. So if let's say I am in the customer complaint department, okay, so I will only be worried if there is a customer who is angry or maybe not satisfied. So in that case I will identify. So what we will want to do is we will want to identify anger, we will want to identify the satisfaction level of the customer. Okay, so this is if I am working in a customer support department. But let's say if I am working in a marketing department or if I am working in products development department, then I will be worried about how my products are, which products are selling more, which feature the people are liking more. So I will be considering the happy customers. I will have to look at the feedbacks from the happy customers, the reviews from the happy customers, right? So in that case, I will only identify the happy customers, the happy feedbacks, and then I will try to identify which product is the one which the people are praising the most, so that maybe I can improve that product, or maybe I can create products similar to that product, right? I can create more products like that. So that is how why we will need this identification. So how you can do it is very simple. You can simply see, is the writer of the following review expressing anger, and the review is delimited by the triple backticks. So you need to give the answer in either yes or no, and then you give the review text, right? And then we are simply getting the completion. So what we do, so in response it is saying no, so it is saying that no, the customer is not angry, right? So which is correct. Next is to extract the product and company name for from the customer review. So this is basically, let's say I am using Twitter, okay, or X, for getting the top products or top companies which are creating coffee mugs, okay. So what I can do is I can go through all the reviews, I can go through all the tweets which are there, and from all these tweets, from the entire collection of those tweets, I can see that okay, these are the customers who are happy with so and so product, the coffee mugs, and this is the company associated, so I can filter that out. So what I can do is, instead of me looking at all of those reviews and trying to understand which one is good, first of all I'll have to filter all the coffee mugs, then I'll have to filter the reviews, which one are good, which one are bad, which one are the best, and then based on that I will be able to then I will have to extract the product, then I will have to extract the company name, right? That is a very long process. All I can do is I can simply copy all the tweets and pass it to LLM, and give a simple prompt to LLM and ask LLM to do this for me. So this will save me hours and hours of hard work. How do we do that? So we can simply give the prompt. So this prompt is where we ask it to identify the following items from the review. First thing, the item purchased by the reviewer. Secondly, the company that made that item. Okay. And we are saying that the review is delimited with triple backticks. Format your response as a JSON object, because I want only the item and the brand, right? So we are giving item and brand as the keys, and if the information is not present, then you use unknown, so that we don't get any junk values. Either we are getting the item and the company name, or we are simply getting unknown. So by this, what we can do is we can in the final processing, we can remove all the lines which contain unknown in them, so that we can only have the data about the item and the company name. So let's have a look at this. So here we have got the review. This is the review, and inside this we have got the JSON, where we have got, for item we have got the name, that is lamp, and brand, that is Lumina, right? Pretty simple. And again, if the prompt doesn't work, you will use the few shot prompting, right? So it is as simple as that. You will improve your prompt iteratively, and all the guidelines which I have been telling you will be sufficient to do your prompt engineering, right? You don't need anything else outside of this course for it. Next thing, that we want to do multiple tasks at once. So what are we asking it to do? We want it to identify the following items from the review, right? We want it to identify the sentiment, and then we are also giving that it needs to identify the positive or negative sentiment. And see, we are breaking down the task for it, right? Then we are asking, is the review expressing anger, true or false? Then we are asking the item purchased by the review, and then the company that made that item. And finally, we are asking it to put it in a JSON object with sentiment, anger, item, and brand as the key, right? If the information is not available, then we are asking it to use unknown. So what do we get? We get sentiment as positive, anger as false, item as lamp, and brand as lumen. Next is when we want to infer a particular topic, right? We want to identify the topic. This could be, let's say we are a news channel, or let's say we are paparazzis, and we want to know everything about the K-pop idols, let's say. So what we want to do is, we will be going through all the news items that are there, and from all the news items we will try to find out what news item is about our K-pop idols, right? And based on that information, that piece of information, we will try to do whatever we want to do, right? So as simple as that. Here what we are doing is we are inferring this particular story. So this is just one of those news articles, right? So it is saying that in a recent survey conducted by the government, public sector employees were asked to rate their level of satisfaction with the department they work at. The results revealed that NASA was the most popular department with a satisfaction rate of 95%. One NASA employee, John Smith, commented on finding, stating, "I am not surprised that NASA came out on top. It is a great place to work with amazing people and incredible opportunities. I am proud to be a part of such an innovative organization." The results were also welcomed by NASA, and a lot of things are there. Fine. So looks like the article is about NASA. So what we want to do? We want to determine the 5 topics that are being discussed in the following text. Make each item 1 or 2 words long, and format your response as a list of items separated by commas, right? And then we pass the story to it. What we get as a result is basically, here are the 5 topics that can be determined from the text. And first one is satisfaction, which is satisfaction with work, department, organization. So basically it is not just giving the topic, but it is also giving the context associated with the topic. So employees, but what employees? Public sector, NASA, Social Security Administration, then job, organization, government. So these are the 5 topics that can be determined from the text itself, right? So these are the different topic list which we extracted from it. Now what we can do is, one thing we can do is we can extract topic from the text. Second thing which we can do is that we have a list of topics, and we want to check that if the article actually contains anything related to that topic, right? So if I want to write only about, say, astronomy, if I want to write only about say, medical, and I want to write only about sports, then I will just search about only these 3 things in the articles, and if there is some relevance, then I will keep them. Then I will try to edit them or put it in my magazine or something like that. Otherwise I will skip that, right? So what we are doing is make a news alert for certain topics. So determine whether each item in the following list of topic is a topic in the text below, which is delimited with the triple backticks, obviously. So give your answer as a list with 0 or 1 for each topic, right? So we have given the list of topic. So what do we get? So the from these topics, the text actually contains NASA, local government, engineering, employee satisfaction, and federal government. Right. So this is how we can make different type of inferences, right, and find out if a topic is there or article is relevant to a particular topic, and a lot of things around that, right? Transforming. So this is another set of tasks which we can perform using prompt engineering in LLM. So the first one is translation. So obviously, because LLMs are trained on a lot of data in a lot of different languages, so they do hold the context of words in different languages. So they can easily be used for translation, and it is very easy to do. All you have to do is you will have to specify that you want to translate from X language to Y language, and it should work for you. Now, another thing is you can use it for tone transformation. Tone transformation is basically if you want to change formal tone to informal tone, or let's say you want it to be something like how Shakespeare used to talk, or how Einstein used to talk, or maybe how pirates talk, those kind of things. So you can try to change that tone. Then format conversion is basically, let's say you have JSON format and you want to convert it into, say, Python, or if you want to change it to XML. So if you want to convert a piece of code from Python to C++, so all those things could be done using format conversion. So what maybe it could be not that good if it is not actually trained on these languages, but mostly it will work somewhat. So you can do those kind of conversions. Then you can perform spell check, grammar check, because obviously these models are trained on these grammatical data. It's trained on huge amount of data, and the data already holds a lot of good grammar, right? So you can perform grammar check, you can perform spell check. So these are different tasks which we can perform for transforming, and we will see the same in the code itself.
Now let us talk about different type of transformations that are available. Now these transformations are basically how you modify the result which you got. Now basically it's changing the text, not generating, but simply changing the text. Okay. So how we are changing? The first one is translation. So translation is basically translating one piece of text to another language, right? Because LLMs are trained on a very large number of languages, so it knows the grammar and the context and what type of words comes after another word, and the context of a word, the meaning of the word in the word space, right? And based on that itself, it knows the same thing about different words in different languages. Right, so that is why it is capable of translating your text as well. So here, the first prompt is basically to translate. So what we can simply say is that translate the following English text to Spanish, and we give a English text that is, hi, I would like to order a blender, right? And what did we get the output? So in the output we got, please provide the correct Spanish translation. So what we can do is we can maybe try to run this again. So it is saying, so it has generated a lot of different words, a lot of text, and translated that text into Spanish also. Starting is same. Oh, sorry, I'm like not really good at Spanish. I don't know Spanish, so this is something what it has translated it into. And this is another, so it what it has done is that because the length of the output could be a longer one, right? So it has basically generated a lot of different English text and given the Spanish translations for the same. So what you can do is you can pick the first one out of this, right? So you will get these type of responses. If the model is very well trained, you may get this kind of response. If the model is not trained that well, you may get no response at all. So things may vary, and things vary a lot. So what you will be have to do is, first of all, for this kind of scenario, most of the time you will be picking up the first out. In case you get this kind of result where you are getting a lot of different sentences translated to Spanish, so in that case you will have to perform instruction tuning such that the model generates only one set of translation and not all these hundreds of sets of English and Spanish translation corresponding to each other. Right? So this is something which you can do as part of instruction tuning. But if you are restricting yourself to prompt engineering, so in that case, the best you can do is you can ask it to translate the text to whatever language you want it to translate to. Right? Another thing which you can do is you can give it a word limit, or you can also ask it to maybe give only translation for this sentence and then end the result. Don't generate anything else. Now, in case you want to run the file again, like I have to run the file again now. So what I can do is I can simply go to setup and then I can minimize this and click on this button. This will execute all of those 8 hidden cells which are there, which are meant for setup. So if you want to run a particular topic collectively, you can just click this button. Now we will get back to our topic, where we were, that is translation. So we have performed translation and I just tried to rerun this entire thing again. So when you run this again with the prompt saying perform one translation and end the response, in that case, it gives me this result. They basically translated this is hola and whatever the translation was, right? Now next is where we want to get the language. So here what we have done is we are saying tell me which language is this text given below, and then combine this is the text which was given. So again we are running this thing. So when we run this thing, the response is that the text is in French, which is written as FR and in ISO 6391 format. So it is giving me the value also, that is the language also, and the ISO format as well. Right? It is some additional information which it has provided me. Now, apart from that, this is basically the text is translated to how much does the street lamp cost, right? So this is the translation. We didn't want the translation, but because this is get completion and it tries to give as much information as possible, so it keeps on giving things. Okay, so what it does is it basically again it keeps on giving the information that this is the translation and in English, which is in this particular format. And to convert text to English, you can use language translation tools and a lot of extra stuff which you don't really need, but it is giving us the required response initially. Right? Now, next thing is translate the following text to French and Spanish and English pirate. Okay, I want to order a basketball. So what it has done here is, here it has given this. This is in French, this is in Spanish, and this is in English pirate. Right? So again, the thing is that as many times you run this will give you a different answer. Basically, because we have given the temperature uh, to be a value which basically allows it to have multiple answers to change the vocabulary which it is writing in. But if you give it a, let's say, only top 1%, or maybe you allow it to have temperature as 0, in that case it will give you only the exact answer, only one answer every time. So if you want to have repeated answers, you could have a lower temperature value. Now next is the prompt. So here we are saying translate the following text into Spanish in both the formal and informal form. So we want in formal and informal form. So we are giving the sentence here. And when we ran this, it gave us the translation. First one formal and second one informal, right? So this is translation. Now usually what happens is that this is in case maybe you're traveling and you want to get a translation in a particular language. Now another scene is where you can actually want to have a lot different translations. Maybe I have a organization where I'm getting feedback from all around the world and I want all those feedbacks to be translated in my common language. Then what I can do is I can simply provide all the feedbacks to it and ask it to translate them, right? So let's say I have all these different user messages in different languages. Okay, so this looks like Chinese, Mandarin, and then here it looks like maybe French or something. I'm not sure what this is. So these are in different languages, and we wanted to provide the language of the text in triple backticks. It has to provide which language it is, and then it has to translate it into English and Korean, right? And we are running it into a for loop. So basically it iterates through all of these messages named as issues, and then it basically gives us the language. And we are giving write in 100 words only. We can give write in 10 words only also, or maybe like 15 words, so that we don't get a very long answer. So let's see the answer which it gave earlier. So initially this is what it gave. It gave that provide the language, and this was the question. This is the response. So this is in Korean and this is in English. But this doesn't seem right. It is saying the my screen is flickering. So for each and every language it has given the result. So if we go back, yes, this is the beginning. So system performance is slower than normal, and here this is in Korean, right? Now let us see the next one. See, this is, then this one is my monitor has dead pixel, has pixel that are not lighting. Similar thing, right? So it has translated it into English and Korean. So maybe we can reduce the number of words and run this. Next usage is tone transformation. So for tone transformation, we just need to define if we want it to be a formal tone or uh, any other kind of tone, right? So here we are saying translate the following from slang to a business letter. So basically we can give certain pointers, and we can ask it to convert it into poetry, into an article, into a letter, or in an essay, whatever you want, right? You can change the tone of it. So here it has basically done the same. So it has changed from this slang to a letter form where it is saying greetings, and then it is giving all the details basically in a letter form. It has written it. Next, we have the format conversion. So format conversion, basically we have given a JSON object, and from the JSON object we wanted to translate it into a Python dictionary from JSON to HTML, right? And the table with column header and title, this is the JSON. So for the completion, so here it is writing Python code, and this Python code is basically creating this table format. Okay, so basically we have this Python function and we have this table creation here. Then we have creating function to generate HTML title and table. Here it is generating the title, restaurant employees. Then it is generating HTML, and based on this it is generating the HTML for it, right? So basically it has completed this. It is for Python dictionary from JSON to HTML, right? And here we have just taken the output and we have printed it. Now next is spell check in grammar. So you can perform spell check and grammar check, because obviously our models are trained on a lot of huge data and they are capable of understanding the grammar and everything. So we can do that. So here we have a lot of text given, and from this text we wanted to proofread and correct the following text. So this is the result. So it has given this response for each and every text. So the first response is, it's going to be a long day. Does the car need its oil changed? Right. So if you see in this original one, this is what is written. It's a long day. And it has changed it to, it's going to be a long day. Does the car need its oil changed? Right? It's going to be a long day. Does the car need its oil changed? So it has corrected the its, right? So similarly, it has done the same thing for all other sentences also. So let us see the original sentence. There goes my freedom. They're going to bring their suitcases. They're gone. There goes my freedom. They are bringing their suitcases. Looks nice. So similarly, you can see all the results which have been corrected. Now next one is basically we have this entire text and we wanted to proofread and correct and this entire review, right? So this is what the response we have got. Review, this plush panda toy is perfect for my daughter. So you can see this entire result has been generated after completion. Now simultaneously here we have just proofread and corrected the review. In this one we have asked it to ensure that it follows APA style guide and targets an advanced reader. So when we say targets an advanced reader, so In that case, it will have a more higher vocabulary, right? So I will highly recommend the plush panda and other parents looking for a gift in their child. Panda, make it a worthwhile investment. So if you see here, those kind of details are not given, but here in this one, it has actually given an advanced vocabulary to it, and here the output in markdown format. So if you in case copy this and paste it into the markdown, it will give you a better view. So you can maybe just copy this, and if I add it to text, so you see this is in a good format, right? So it has formatted it into a markdown. So this is all for translation transformation. So in case of transformation, we have talked about translation, universal translator, tone transformer, format conversion, and spell check and grammar check. So basically, in case of transformation, you are able to transform the given result into a better version of it. Again, you can ask for a better format, you can ask for change in tone, you can change the language which has been used by translation, and you can also ask it to keep it in a simpler vocabulary, maybe like in a 5-year-old vocabulary, or maybe you can change the vocabulary to something like for someone who has advanced knowledge. You can ask it to add jargons, you can ask it to remove all the jargons. So those kind of things you can ask for it.
So let's talk about expanding. So for expanding is basically how we perform summarizing. So in summarizing, we try to summarize the text, right? We try to get the major points out of the data. But now in case of expanding, we basically want to expand on a topic. So basically we want to write more about a particular topic. It could be like certain pointers could be given and you want to write an article on it, or maybe you want to create a email or letter based on a particular pointers or draft. So basically you want to increase the size and add some details to the text which you have. So what you can do is you can use it to maybe customize a particular response. So basically if you want to have some particular language in the text, or if you want to add more details, like writing an automatic reply kind of a thing. So basically you will be using the specified details and then writing the entire text about it. So that's what LLM would be doing using your prompts. Now next part here would be the context, in context learning, zero prompt, short prompting, few short prompting. Then these are majorly the types of prompts which you provide when your model is not really experienced in what you want it to do. So in that case, you provide it a little idea on how it should be solving the problem. So we have already discussed this in earlier also, but we will look at it a little more in detail. Then we will have a look at how you can specify the output format. You can provide how the output should look like, how you can use role prompting. Role prompting is basically when you want to suggest or provide a role to your LLM. Like you want it to be calm and use a informal tone. You want it to use a formal tone and use a lot of jargons. Or if you wanted to explain everything like it is explaining to a 5-year-old child, or maybe you want your chatbot to be like let's say a pirate. So those kind of things. Or maybe you wanted to respond, maybe you can ask it that its role is of a poet and it needs to respond to every question in a poetry, right? So that is how you define different roles. And lastly, we will have a look at summarization, how chain of thought prompting works. So all these things we will discuss about. in this particular session.
Now let us have a look at expanding. So we will try to expand some data points here. So the first one is to customize the automated reply to a customer email. So here what we have is that we have an original sentiment. This sentiment is negative. Okay. So given the sentiment from the lesson in Infring and the original customer message, customize the email. So this is the sentiment which we have, and this is the review. Okay. So this review basically says that they still had the 17-piece system on seasonal sale for around $49 in the month of November, about half off. But for some reason, call it price gouging, around the second week of December, the prices all went up to about anywhere between $70 to $89. That is twice of it. And the 11-piece system went up around $10 or so in price also from the earlier sales price of $29. So it looks okay. But if you look at the base, the part where the blade locks into place, it doesn't look as good as in the previous edition from a few years ago. But I plan to be very gentle with it. Example, I crush very hard item like beans, rice in the blender. First, this is this. So she's maybe giving some details about it. Now, if I need them finer, special tip when making smoothies. So she's telling how they should be doing it, he or she, whosoever. And then tip when making smoothies. And then after about a year, the motor was making a funny noise. I called the customer service, but the warranty expired already, so I had to buy another one. FYI, the overall quality has gone down in this type of product, so they are kind of counting on brand recognition and customer loyalty to maintain the sales. Got it in about 2 days. So the person is not at all happy and the feedback is negative. So what we are saying is you are a customer service agent, AI agent, and your task is to send an email reply to a valued customer. Given the customer details, now generate a reply to thank the customer for their review. If the sentiment is positive or neutral, thank them. If the sentiment is negative, apologize and suggest that they can reach out to the customer service. Make sure to use specific details from the review. Write a concise and professional tone. Sign the email as AI customer agent. And then we provide the customer review and the sentiment. And we wanted to complete it. So let us see the response. This is the email. Dear valued customer, thanks for taking the time to share your review. We are sorry to hear this. Regarding the quality, we appreciate your feedback and will ensure that we look into this matter. Our goal is to maintain highest quality standard and we will work to improve overall quality of our blenders. We would like to suggest you to reach out to our customer service. We will be more than happy to address any concerns, right? And then it also signed it with AI customer agent. So it looks perfectly fine. No issues with it. Now, next is remind the model to use details from customers' emails. So here we have, so next is role prompting. So we have seen earlier also that you can define a role for your assistant, right? You can tell the assistant what tone the assistant should be talking in, right? So here what we have done is we have given it, how can I answer this question from my friend? What is the meaning of life? So it's simply asking how can I answer for a friend. So I'm not sure if my friend is asking this question in a philosophical or a religious context, but here is the response. In each and every context, it is giving the response to us. Okay. Now we are defining a role, okay, and the tone. So in role, we are giving your role is a life coach who gives advice to people about living a good life. Your attempt to provide unbiased advice, your response in the tone of English pirate. So we in the prompt we provide the role initially, and then you provide the same prompt repeated. Now, why do we give the role separately? We will not want to write the entire role here. Okay. So maybe what you can do is while giving a prompt, you might create templates for different roles. Okay. You might create one template for a formal tone. You might create a template for informal happy tone. You can create a template for a formal with maybe supportive person, friendly person, that kind of tone. So you can maybe create your custom tone, custom role, and then based on that custom role you can give the response. Okay. Now this response can also have something like you have to respond only in Korean, you have to respond only in Spanish, and then you can also maybe give a specific dialect, right? So those kind of things you can put in the role itself. So here it has done the same thing. So here it is basically given the response in pirate tone. Okay. So this is what is known as the role defining. Okay. So we are defining the role for the person. Now, next is providing new information in the prompt. So basically, this is to prevent hallucination or maybe to make sure that it is not hallucinating. So what you can do is here, basically the model will have a restricted knowledge. For example, in case of Llama 2, the knowledge is restricted till July 18, 2023. Similarly, for Gemini, OpenAI, ChatGPT, for all of the models, there will be some restriction in the data, in the knowledge. Although Gemini suggests that it does not have a restriction on the knowledge because it has direct access to Google data. So Gemini will be able to answer such questions more appropriately because it can actually access Google. Okay, so you can keep these things in mind. So here we basically have this prompt. So this prompt is who won 2023 Women's World Cup. So when we run this, it is saying that according to 2023, the Women World Cup is set to kick off in July. Okay, so it is saying that it is going to happen in July, and it is trained till July to the 18, and the World Cup was started on July 20. So it will not have the information, right? But it is giving different details like who will be playing, who is probably winning, right? So what we can do is we can provide information. So here what we can do is here we can provide the context to it. So here we are telling that the 2023 FIFA World Cup and was the ninth edition, and we're giving an entire article on it, and we are telling who won, who lost, and all those details, right? So using this context, we pass this context in the prompt itself, and then we ask, given the following context, who won the 2023 Women's World Cup? And then it is responding that based on the material given above, who won the golden ball, golden. So basically gave no such response majorly, but it should give you the response as an Australian team nickname Matildas. So if you run this code again, right, if you run this maybe once or twice, then with certain modification, it should give you the correct response. But even if it is not giving you response like this, then you can use RAG, which is again the same thing, which uses different documents to give you the response. But again, because we are using this model and the temperature is higher, then it is not giving the answer. So what we can do is we can again make certain modification. So I'll reconnect and I'll change it to T4. So I just connected to T4. I'll go to setup AWQ. I'll minimize this and I'll run the setup for AWQ. And I can also stop this actually. I can maybe interrupt the execution and I will make certain changes. Like this time, I will make the temperature as 0.05 and I'll give it top 95, and then we can maybe try to run this. And once this is run, we can go to provide new information, and here we will run this. The context, and I'll just copy this, add a cell here and run this again. And then just run this. So let's wait for the response. So now let us have a look at what is in-context learning. Now, in-context learning is basically trying to understand and learning from the context which is provided in the prompt itself. Right? So basically your LLM model is trained separately, and after the training, you try to give some more information to your LLM to learn from the prompt which is given and then learn to give a correct response. Okay, so in case of in context learning, the first thing is standard prompt with instruction. So this standard prompt is basically something which you have been doing till now, or what you do in your daily life, right? So basically you tell the LLM to do something, to perform a particular option. So this is one action which we want the LLM to perform, which is we wanted to tell the sentiment of this particular sentence. Okay, so what is the sentiment? And the sentence is, "Hi Amit, thanks for the thankful birthday card." Now we have asked it to provide a sentiment. Now, this is a normal LLM, and this is not something as huge as Gemini or your ChatGPT. So, obviously, this one is not that proficient. This won't know how to work at that. So, what this will do? It is saying, "I'm glad you like it." So it doesn't really know how to respond to it, but because based on the data it has been trained on, so whenever there is a text where it is being said, "Hi, thanks for the thoughtful birthday card," there it always follows with someone saying, "I'm glad you liked it," or "Thank you for giving it to me," or something like that. Okay, so this is a very common response. That is why the LLM responds with this thing. It doesn't know that it knows that sentiment is there, but it is, but based on the probability which the LLM has been trained on, the LLM thinks that the highest probability of the next word or the next sentence should be, "I'm glad you liked it." Okay, instead of saying this is a negative sentence, this is a positive sentence, it is trained in such a way that it is trained to complete a sentence, and the most obvious completion to thanks would be, "I'm glad you liked it." Right, so the LLM is not wrong, but it has not been trained for this task. But you can do one more thing. What you can do is you can train this model to follow the instruction or to perform a particular task. But we are learning prompt engineering, so we need to do it via prompt engineering, right? So this won't work for us. So we need the model to learn from what we are giving via prompt, because prompt is the only way how we can communicate with the LLM, right? So how do we tell it? We will be going to the next thing, which is zero shot prompting. So in case of zero shot prompting, what we do is we basically tell the model that this is the structure which you want to follow. Okay, I will be giving you a message and you need to respond with a sentiment. That's all what we are telling it. We are not giving it an example in case of zero shot programming. We are simply telling it that this is a message and this is a response which I need. I'm giving a message, and in response I need you to provide a sentiment. That's all what we are telling. Now based on this prompt, it actually gives us this response. So the response is that based on hi, thanks for the thoughtful birthday card, it says sentiment gratitude, then appreciation, then kindness. Although it is giving us multiple responses, but that is perfectly fine because we didn't ask it to give just one sentiment and then stop the response, right? And this has a longer length which is possible for the response. So it is giving us all the possible responses, all the possible sentiments, but that is perfectly fine because it is still acceptable. It is at least giving us some response, right? And this actually evolves, and this actually improves in case of larger LLMs. It improves as we train them in a different way. So because we are just doing prompt engineering, so this is not our concern. Our concern is to get the correct response initially. Okay, so this is zero shot prompting where we are telling only the structure, but we are not giving any examples. Now, next option which we have is we have few shot prompting. So in case of few shot prompting, we provide the structure, and along with the structure, we also provide 2-3 examples. Now, usually when you are training in a model, right, when you're training your machine learning model, it doesn't work with just 4-5 examples. It usually takes thousands or 2,000, 10,000 different rows of data to actually train your model to get the correct response. But the LLMs are good enough, so they can actually learn with just 2-3 good examples, and you don't need to give those 10,000 or 5,000 different examples. And it will also not work really well if you keep giving 50 or 20 examples. The performance will not improve. So don't worry and don't even bother giving so many examples. If it is supposed to work, then it will work with 2-3 examples. If it is not working, it won't work with even hundreds of examples. Okay, so you need to make sure that you're giving 2, 3 to 5, at max 5 examples. Okay, don't bother giving so many examples. Give 2-3 examples at max. And you can basically keep on trying. You can give zero shot. If zero shot doesn't work, you can give 1 shot, 2 shot, and accordingly you decide. Never go above 5 shots. Okay, so this is few shot prompting. Don't go more than that, right? So this is another example. So basically what we're doing here, we're giving the message. This is the message and this is the sentiment. So we are giving it an example that I'll give you a message, then you'll give me a sentiment. Then I'll give you another message, then you give me another sentiment. Right? So here we are simply saying that when we give this message, now you provide the sentiment for this. So what it does is it basically gives us the sentiment accordingly. So it gives us hi dad, then can't we wait, and for hi Amit, the question mark. So this is the response for it. So here what it did, it basically created a new example for us. Okay, so it created a new example for us. It is basically creating a new example. Instead of giving a response for this, it actually gave a response saying, I am so excited to finally be moving in a new apartment. So it created a new sentence and gave a response for it. Now, what we can do is, let us give it another try. Okay. Now, what we will do is, I'll just run this again with removing this sentiment here. Okay. And then let's see what this gives as a response. So here you can see I modified the response. So basically I said give sentiment for message given in triple backticks and end response, and I put the message in triple backticks, and in the response I got sentiment as positive. So this is how you can use the few shot prompting. You might have to change the prompt slightly, but mostly how this would be working.
Hello everyone. So in this session we will talk about different tools which you can use for image generation. So some of the tools I have here, one is Playground. So this is playground.com. So they basically have two type of models. One is your stable diffusion model and its different versions. Then apart from that they have their own diffusion model which is Playground. So we will talk about that and we will see how we can use it. Apart from this, we have another one which is Midjourney. Midjourney is again a very good tool, but the problem is that it is a paid tool. So you will have to pay to use this Midjourney tool. And when we talk about Playground, again there is some payment. Sometimes we have to use payment, sometimes we don't, depending on what services you're using, so it will charge you accordingly. But then there is another website which is leonardo.ai, which is a very nice tool and it is also free of cost. So the most preferred one I would say is leonardo.ai because it is free of cost. Then again it is completely up to you what you want to use. First I will show you Playground. So this is Playground, and here you can see we have different images which have been generated and their corresponding prompts are also given. I've selected this tab which is pure prompt, and apart from that we have different tabs like, let's say, food. So in case of food we have this particular one. Let's see what this is. So for this you can see this is raccoon cooking in the kitchen, and the prompt which was given to generate this image is raccoon cooking in the kitchen sticker. It should be in a sticker form, 2D, cute, fantasy, dreamy, vector illustration, 2D, flat, then Tim Burton. So basically it is some style by Tim Burton, who should be an artist who creates these kind of graphics. Then vector graphic, and this is a positive prompt. This basically describes how you want your image to look like, and you tell that it should be sleek, modern. Then remove from image is basically your negative prompt. So when we are doing text to image generation, we usually provide a positive prompt and a negative prompt. Positive prompt basically what you want to have in your images, and negative prompt is basically what you want the model to avoid while generating this image. It should be ugly, deformed, noisy, blurry, distorted, out of focus image, bad anatomy, extra limb, poorly drawn face, poorly drawn hand, missing fingers. Right? So these are different prompts which you provide for a negative prompt. Now, what is the need of giving a positive and negative prompt? Positive prompt, obviously, because you want AI to know what type of image you want to generate. So that is why you give certain prompts, and based on the prompts, the model already have a embedding. If you remember, there is a text embedding which is present in your diffusion model, which contains the meaning of that word, and accordingly it is able to create an image similar to that particular identifier or that particular object which you have given in form of text. And to remove from image, Again, these are the things which will be told to the model that these need to be removed. Why are we telling these kind of things to the model? Because sometimes we don't want specific things to be present in the image, or something which could be not useful. So maybe let's say I want to create an advertisement, and in that advertisement I want to have images of people doing exercise, but maybe I want the images to be indoors and not outdoors, or I want to have people doing exercises, but I don't want them to have any specific kind of machines on which they are exercising, or I want them to have those machines. So these kind of things I need to put in form of positive and negative prompts, so that the model knows what needs to be there and what absolutely cannot be there in the image. Another thing is, when we are creating the image, while generating the image, we provide the size of the image as well. When the size of the image is small, the model is able to generate a lot of things easily. But when the size of image increases, so let's say when we are talking about 512 cross 512 pixel image, the image would be generated nicely. But instead, if I double the dimensions, in that case, the images are sometimes having some abnormalities. Maybe there are extra limbs, there can be multiple heads in the image, the person can have multiple hands, multiple arms, the number of fingers could be wrong. So these things are which are possible when you are increasing the size of the image, because the model works well for a particular size, and when you increase the size of the image, then it causes those issues. So that is why it is important to give these kind of negative prompts. One more thing is that when we are generating a particular image, at that time we usually tend to generate a smaller image with whatever we want the image to have, and then when we increase the size of the image, the dimensions of the image, we basically simply enlarge the image itself. Okay, so if you want to do that, there is this one option, and another option is when you want to directly create a large image itself. So these are two different things. One is you are creating a large image itself. At that time, the image generator will have to put in a lot of more things, or generate a lot of different things in for that particular area of the image. But when you have already developed a smaller image and then you want to increase just the size of it, okay, in that case the image generation doesn't have to do anything. It will just have to improve the quality of the image. So these are two different things, right? That this is where this negative prompt comes in place. So basically you are not generating a larger image initially, so those extra limbs will not be generated. But if you are not generating that large image initially and increasing the quality later on, at that time we are on a safer side, so you may avoid these negative prompts. So this is one thing which you always need to keep in mind. Now, while generating the image, first thing is you need to provide these prompts. Apart from that, you can provide a seed if you want to have a specific image to be generated over the period of time that you always want this image to be generated. Then there is this sampler which you have to select. DPM++ 2M Karas is a good sampler, always gives good results. Then we have the model. So when we talk about model, there are different models. Stable Diffusion 1, Stable Diffusion 1.5, Stable Diffusion 2, which are basically good models and improving over the versions. And Stable Diffusion 1.5 and Stable Diffusion 2 are highly used ones, and have a lot of different plugins available, like different LoRa's available for styling. When we talk about Stable Diffusion XL and Stable Diffusion Turbo, which is another more higher variant of Stable Diffusion above Stable Diffusion version 2, that one is actually even more better because it is able to generate large size images also very easily and without the issues which I was talking about earlier. So that is again one thing. We will talk about this also, and different samplers as well. How do we decide them? These things we will talk about, but initially I'm just showing you about the prompts. Next thing, we have a guidance scale. So guidance scale basically helps you in deciding how much you want your image generator model to follow the guidance which you have provided in form of the prompts, the positive and negative prompts. If you want the model to uh, take lead and develop something on its own and you don't want to provide much inputs, then you can select the guidance scale of 3 or 4 up till 6, 7 is fine. But when you want the model to follow your prompts closely, then you should say give around 10, 12 or 13 or up to 15, which means that you want the model to take your input seriously. You want it to create based on your prompts which you are giving. uh, Basically low, medium and high. So low is around 3 or still 7, medium is still 12 or 14, then we have high which is above 15. So any guidance above 12 or above 15 basically means that you need to completely stick to my prompts and don't make any of your own decisions. Create something very, very, very specific as I am saying in my prompts. My prompts are absolutely correct and this is exactly what I want. So that is what this guidance scale means. You are giving the model liberty to generate image in your guidance scale 3, where it is a lot of liberation. You tell it, okay, do whatever you want. This is maybe just a cat which I want, but no matter, you decide how you want that cat to look like. And when I say guidance scale 15, I'm saying that the cat has to look orange in color and should be dancing and doing something or very specific things. So that's what guidance scale is. Now, apart from guidance scale, we have different filter styles. Now, these filter styles are present in form of different LoRa's or other type of plugins which we have. So again, these things we will be talking about. Apart from this, let us see any other image if we have. Now here we have another example and you can see so many details what the prompt are given here. It needs the close-up of a cute, slightly angry, you can see the anger, right? Latin American baby girl with big eyes clutching a furry cat, featuring modern vintage elements. It needs to have heavy brushstrokes, textured impasto oil technique, right? And we are removing all these things. So let's copy this and let us try to create this thing. Okay. So if you see it is remixed from this particular image, let's go there. You can see sampler is LMS Caras, model is Stable Diffusion XL, guidance is 7 and filter is duck heighten. Okay, let's go to this image. It's reference image. Okay, that page is not found. So let's create a new one. Okay. So in this frame here we can provide the prompt. So I've pasted the prompt here, and here I'm saying the guidance to be low. I'm giving guidance low because low guidance is basically around 7, then you have medium and high, so I'm giving low. We'll see images at different guidance levels. Now model, we will take Stable Diffusion XL. We have two options, Stable Diffusion XL and Playground V2, so we'll take the same one. Here we have different presets, different things if you can choose. So let's choose Fantasy World, and here let's change this and paste our prompt. Let's pick the filters. So let's pick the filter that the person had used. Okay, this is probably a premium kind of a, okay, so let's select something like, say, macro realism. Let's try this. Let's generate. Here you have option for prompt guidance, how much value of prompt guidance we want to give. Then the quality and detail. This is the number of steps basically. Number of images and the sampler which you're using. Usually DPM, Caras and Euler, these work pretty well. And here if you see, these are pros. So let's see, this image is getting generated. So here you can see these are the images which have been generated. So if you see, this one is quite deformed because it has merged the face of cat and the girl. So the girl's face is not clear and it has this deformity here. Here the girl's face is not visible at all, but we wanted the girl to look angry. These two look pretty well. Okay. Then apart from this, if you go to board, we here have more options. Like if you want to expand the prompt, or if you want to provide some negative prompts, you can give here. Now if you want to edit a particular image, what you can do is you can select this rectangular area and you can move this frame to whichever image you want to modify. Once I select this image, it gives me certain options. I can select these different LoRa's, basically different type of filters and different presets. You can create a preset also. By selecting different type of filters, model, prompt guidance. So like this, what will happen is all your settings will be saved and you can pick a specific type of setting. Now let's select stable diffusion, and here we'll give prompt guidance, say around 4, and we'll create only one value here, and again we'll select the same prompt. Okay. Now if you see, we have this outpaint option instead of generate. What this outpaint does is, if you increase the size here, or maybe if you move the frame like this, then it will be able to add something to this image. So I'll click outpaint. So now it will generate this part for this image. This actually takes quite some time. It's 45 seconds, but still it has not been generated. So if you see here, it has generated the next part of this image. So if you want, I can add more area to it. Like this, it will keep on growing the image. So you'll be able to grow the image, okay? So maybe I can add something to it. Sorry, cat near a beach. Now it will be difficult to see basically how it is able to add beach to it. Let's see if it will be able to do this. So it still was not able to give the beach thing. So let's try again. And one more thing, if you notice, is it is able to create the continuity as well. Here it is able to give the lighting accordingly and this background also, and it joined the dress accordingly. I really want to see this cat up close. So it is showing as if the girl's hair is in front of her hand. It has also given some jewelry, some rings are there. See, some kind of rings are there. See the detailing which it has given to the image. See how it has created that image. Now see, here the deformity comes in. Now because we have outpainted, it has started giving something which should not be here. If you look at the bigger picture, this doesn't really make sense in the image, right? And this area also. But still, it did a pretty good job here. So let's have a look at another tool. Next tool is leonardo.ai. So you can see this is the host page. Let's go further. You will be able to sign up using any of your IDs, and once you sign up, you can select your interests and click next. Then you go to this page where you can select if you want to create some images or not. And here you can see different images which have been created. See, such a realistic kid. Now what we can do is, let us create something. Let's create something like this. So this was the prompt. Let's copy this prompt, and here this is the resolution. So let's generate something, okay? So we can go to image generation, and inside image generation you can see these are the tokens which are available. There are limited 150 tokens. You can upgrade it or keep on reusing once you get new tokens. Okay, so I'll just create one image, and here we have two options. One, if you want to have a photo reel, which is basically real kind of an image, or you can remove the option of photo reel. Okay, if you select the option of photo reel, this Leonardo photo reel will basically not be there, and you will still have certain options of filters which you want, and apart from that you will be able to add certain elements. Okay, these elements are nothing but different type of loras. Okay, you can add element like if you want it to look like a coloring book, or if you want to look like a illustration or cybertech or dragon scale. So let's say I want to make it look like dragon scale, and then I'll select this, and then this is the weightage of the LoRa. Okay, so let's say I want to give 0.6 as the weightage of LoRa, and here I have certain options if I want which version of Leonardo I want to use. Version 1, version 2. Okay, in version 2 we have Leonardo Diffusion XL, Vision XL, Kino. So let's say Diffusion XL and save this. Then in Alchemy, you can also see this question mark to know what this is. So Alchemy is basically powerful image generation pipeline. So here we have option for selecting the output resolution. Then here we have advanced control, the aspect ratio which you want. Then here you can change the width and height. This is for the guidance scale. Then this is the recommended size, the seed which you want. Then here we have image guidance. In image guidance you can provide any image so that it can create a similar image. So if you have a prototype or something like that, you can upload that particular image here. Then we have an option to create prompt. So if you enter some basic information, it will help you by creating different prompts. Now I already know what I want to have, so I just click here and paste my prompt, and then I will click generate. This will take 16 tokens, so I'll just click and generate. Here you can see different things which are used for creating it, and it is still being generated. So this has been generated. Okay, then you have option for editing canvas, Alchemy upscaler, which basically will help you to refine or upscale the image, motion video generator, background remover, more image upscaler, image guidance input. Now let's do one thing. You can see here we have an image upscaler. Now this is what I was talking about when I said that you can increase the quality of the image later on after you have generated the image. This upscaler will basically help you into increasing or improving the quality of the image once the image has been generated. So this will actually avoid the deformities if you are using some lower level of model and not the latest level of the model. So this is the image. So you can see because your account is public, So this image will be public, so whatever you're generating, people will be able to see this. Now let's change this, and instead of photoreal I want to remove photoreal. Okay, and when I remove photoreal, I have certain options available. If I want to create animation style, or different styles are there. So if I want to use stable diffusion, I can select that. And then again I have option for selecting the elements, the type which you want it to be. So let's say I want it to be creative, or maybe anime. Let's go that. And if you want to do, you can remove this also. This is the details in alchemy. I can close the alchemy also, I can start the alchemy also. If I click here, I'll be able to change things. If I want the image to be high resolution, contrast, have some resonance, the prompt type which if I want to have, and so on. So I'll just close this. Then you have these advanced options which we've already seen. So let's generate the image again. I'll just click here. So here you can see this is the new image generated. Right, so this is how you can try and basically generate your own images. Now apart from these tools, we also have an option to generate images using our Python code. So we will have a look at that after this.